All right, good morning again, everyone. Welcome to the School of Engineering Major Project Conference, Day 1. We have an exciting 2 days ahead of us, well, today and tomorrow. And I know, well, this room today is supposed to get a lot fuller. All right, it's a little bit, it's not as full as I'd like to see it, but I'm quite sure there are others who are on their way. And I know tomorrow we're going to be having a larger crowd here to present. All right, so we're going to start off the events by asking Professor Earl Wilson to lead us in prayer.
Can we stand for prayer, please? Psalms remind us that this is the day that the Lord has made. We can rejoice and be glad in it. At least we can save your life today. We give God thanks for that. Let us pray. Father, we come this day in this conference, the beginning of this conference, to give you thanks. In the Faculty of Engineering and Computing, the young people here from engineering are here presented today. And what they're doing, declaring what your word says, showing that you have given them imagination and creative prowess, oh God, so they can display some of the things that they've learned and have applied. So we come today, oh God, we're looking for an exciting time with our students. We're looking for a time that we are informed. And we're looking for a time to give us hope for tomorrow, that the young people from this faculty will be part of the development of our country and our world. As Jamaica seek to enhance the progress of our country, our world. So we ask you to bless us and bless everything that's been done today, oh God. Let the students be relaxed in their presentation between today and tomorrow, God. Let them not be fearful, for we are not judging them to condemnation. We are just pointing them to excellence. We give you thanks in Jesus' name. Amen.
Thank you, Prof. Wilson. I know you're all energized now after that prayer, right? Yes. And just to let you feel a little bit more at ease, when you look around at all the lecturers and all the engineers in this room, note, we were all in this position at one point or another, all right? Some of us did it, had both diploma and degree to do. So please be comfortable. All right. We have today is our focus of today, this afternoon, is a poster competition, and then tomorrow you have your project presentation, so you can relax a little bit today. Enjoy the presentations that you will see. You know, pick up a few tips on the presentation styles, yes? Be comfortable. Enjoy your day. We have, and just a note, Major Project Conference has been going on forever. From the School of Engineering has been in existence, it has been going on in different formats, but this particular format has been on since what, 2017? 2018, yes. So we understand how you're feeling, but we are looking forward to hearing you. And bear in mind, this is a culmination of your work. So be happy about it. After this, after tomorrow, you can breathe a sigh of relief and relax, right? Okay. All right. We have a number of greetings, a number of addresses to happen now. We are supposed to have the president of the university, Dr. Kevin Brown. He's not here yet, but when he comes in, he will be asked to present. So I'll move straight on to the dean's address. The Dean of the Faculty of Engineering and Computing, Professor Sean Thorpe. Prof. Thorpe?
Thank you, Dr. Chambers. Colleagues, all staff, students, a pleasant good morning. It's really my pleasure, second year in a row, to be here engaging with you in this conference. Now, let me tell you, one of the things I've recognized and appreciated about the School of Engineering is the seriousness with which you take the major project conference. From nights ago, since this week, last week, I see many of you all around the place figuring out your projects, trying to ensure that you meet the timeline for today. And that speaks volumes in terms of how you treat with the professionalism of the field. And I'm really elated to be in such good company. I know the hard work over the last year in building out your projects is such that as a team of you, it takes time. Of course, the effort would not be one where it has not been fraught with issues as you go through the period to come to today. But I'm sure many of you would have battled that storm, and all properly dressed and adorned in suits and all of that today is to me indicating the confidence that you have with respect of what you're going to present to the wider community. So I really want to thank the school through its leadership, and to all the directors, the sponsors who support your event. I'm just using my moment to just embrace the fact that it is a community effort, and I want to recognize that wholeheartedly. So I wish you all the best throughout the two-day event, and I look forward to viewing some of the excellent work that you will have presenting. And of course, when you're finished, think about the prospects of moving some of these into startups or companies in terms of the outcome. So don't just leave it as a project, but turn it into an opportunity which you can actually also allow for it to be a part of probably a new business coming out of the School of Engineering. Remember, engineers are really very creative people. You are leaders. You don't wait on others to tell you what to do with what you have actually built. So I'm really looking forward to that. Have a pleasant day. Thank you.
Thank you very much, Prof. Thorpe. All right, when you look around in the room, students, you will see a number of people who you may not be familiar with, but we have some of your assessors here today. Just saw one just walking up at the top there. We have a number of sponsors, and I need to point out who some of the sponsors are. We have Huawei, we have GIE, JPS, Loring, Pepsi, PERB, and if you look in the back of your conference booklet, you'll see a list of all the sponsors, all right? Some of them have booths set up outside. Maybe not all are here right now, but they will be coming in. And as we go through the day, you'll hear a little bit more from our sponsors. At this time, I'll ask the head of School of Engineering to come and address you. Mr. Josephs, Mr. O'Neill Josephs, head of school.
Thank you very much, Master of Ceremony. Dr. Alwyn Ailes, Professor Thorpe, academic staff, students, colleagues, major project committee members, good morning. Good morning. Good morning. Great. All right, so I'm happy to be here. I have something prepared. Just allow me to take you through my speech here. The School of Engineering is pleased to showcase our 2024 capstone engineering projects to our stakeholders at our inaugural two-day major project conference. And when I say inaugural, it's just the two-day component of it that is inaugural. Our major project conference allows students in their last year of study to display their work through presentations, demonstrations, and posters. This is similar to the format of an academic conference. Our event gets better each year, and today we have more staff participation, more stakeholders from secondary and tertiary universities, and more corporate sponsors, both in terms of quantity of sponsors and the volume of sponsorship that is being given. In addition to the fact that we have extended it to 2 days as against one. This year's conference offers a wide range of solutions for our a wide range of solutions for water infrastructure, transportation, agriculture, energy, and new industrial solutions as well. We still believe that a conference like this should be open to the public. So even though it is somewhat constrained to academic staff, sponsors, industry stakeholders, it is our desire that a conference like this will be streamed to students in high schools, students in the community colleges, and other university students locally and overseas. The poster competition will allow for a kind of an in-depth overview of the critical solutions that you have allowed for. And what we've done to spice it up, as we've always done, is to put that into a competitive arrangement where you all compete for the best set of displays, the best set of solutions, and guess what? We have a panel of experts who will adjudicate and decide which poster is the best. This significant event could not have been organized without a strong and effective corporate stakeholder sponsor or sponsors and a strong team of individuals. And at this time, I want to take the time out to acknowledge the major project committee team members, and I'm going to ask them to stand, starting with Vaughn Alexander, who is the chair of the committee. Stand, Mr. Alexander. Put your hands together for Mr. Alexander. I see other members, O'Neill Mason at the back there. I see Evan Brown. All right, just all of you just stand, please. Yes, Mr. Allen, Miss Nicole Booth Thompson, Bora. They've done a magnificent task in putting this together. I tell you, the major project committee is the example of how I envision committees working in the school. They have all the components of a successful committee in the School of Engineering. As we continue to develop, what do we expect to see come next year? Again, we're hoping to have another 2-day conference, but we're hoping that we will open the space, as I said before, to physical attendance of more students, more industry stakeholders, government officials, because guess what? The solutions that you're purporting today, offering today, are solutions that can, in fact, solve real problems that we're experiencing. The Western Jamaica, drought. Roads, there's no capacity. Right now the government is investing $40 billion in Spark program, but there's not enough capacity to spend it. The NAA has a capacity of $6 billion per year, and what we need is 7 NAAs to implement the Spark program. We don't have 7 NAAs. So how will we implement that program? But you, our students, are providing solutions for that. Energy. There are also several solutions around energy. Again, we know electromobility is a big part of the trend that is dominating society, and you've also provided solutions in those respects. Again, well done, well done. I mean, I cannot emphasize enough how proud we are of the work that you have done and the fact that you were able to come out today and display your project. We have a wonderful day lined up for you. Please just soak up the energy, soak up the atmosphere. Some of you will, in fact, go beyond a major project conference paper to do some real academic work and to do even your master's program. We've set the spotlight and the platform for you to do that. This is the pedestal for you, and the future is bright. Continue to do well, and all the best.
Okay, you should all be inspired by that charge from your head of school, Mr. Josephs. Right? Yes, you are. I like to hear that. All right. As I said, the president, Dr. Kevin Brown, is not here yet, but we are moving on with our program. We have a special individual in our midst, and he has to be highlighted individually. And this is Dr. Alwyn Hales, and he is let me get this right, he is the former permanent secretary in the Ministry of Transport and Mining. All right, but to introduce Dr. Hales properly, I will ask Mr. David Allen from the Civil Engineering Program to make that full introduction. Mr. Allen?
Pleasant morning to everybody. Okay, well, let me assist myself. Okay, well, today I have the honor of introducing our guest speaker, who is someone I personally know and regard as an exemplary human being. Having known him all my professional life as an engineer, and even before then, before completing my high school education, this man has for many decades stood honorably in public life as a beacon of hope for aspiring engineers in exemplifying competence, integrity, and professional ethics in the conduct of his work. I speak of none other than Dr. Alwyn Livingston Hales. Dr. Alwyn Livingston Hales was born in Clarendon in 1957. He obtained his childhood education at various schools in the parish, including Edwin Allen High School and Clarendon College. He attended the University of the West Indies, where he attained a bachelor's science degree in civil engineering in 1980. He worked in several entities while achieving a Master's of Science degree in water resources engineering from the University of Guelph, Canada, in 1983, and a PhD in water management from the University of Southampton, UK, in 1994. Dr. Hales was appointed as permanent secretary in the Ministry of Local Government and Works in 1996, and has since served in several ministries in charge of portfolios such as local government, works, transport, housing, urban renewal, water, land, environment, climate change, and mining. He retired in 2023, right, while serving at the Ministry of Science, Energy, Telecommunications, and Transport. Dr. Hales is married and has 2 daughters. Please help me welcome our guest speaker, Dr. Alwyn Hales.
Thank you so much, Mr. Allen. You caused me to have to pinch myself, because I'm not sure if that is the same person you have known over these years. Good morning, everyone. Dr. Brown, not yet here, Professor Thorpe, and Mr. Joseph, faculty members, students, everyone, I greet you and wish you a good morning. It is indeed a pleasure for me to be here today. I unfortunately wasn't able to make it last year, but the pleasure is mine this time around. Last year we were in the middle of some changes within the ministry that I used to work for. That was the Ministry of Transport and Mining, which was, in a sense, closed as the mining portfolio went to agriculture and the transport portfolio went to the Ministry of Energy, Science, and so forth and so forth. It is wonderful to see what is happening here at UTEC, the developments of an organization that even in its former incarnation from those days have always had the interest of Jamaica's development at hand. It is one of those institutions that have been very, very relevant and indeed focus more on practical solution than on purely academic. It is also one of those institutions that believe in the old adage that if you fail to plan, you plan to fail. And I'm going to just quote one little item for you. When Jesus was speaking to his disciples, he said, "For which of you intended to build a tower, sitteth not down first," that is St. Luke 14:28, "and counted the cost, whether he have sufficient funds to build it, lest haply, after he had started, laid the foundation, and he is not able to finish it, all that behold it begin to mock him." And many, many times we have seen situations where projects have started and either get stagnated or have not been able to continue because this scripture referred to funds, but it could be other reasons, circumstances, unforeseen circumstances, or circumstances that arose because of poor planning. Engineers, I dare say, are at the very center of any planning process. Let me first thank the Faculty of Engineering and Computing, and more specifically, the School of Engineering, for inviting me for the, as I said before, the second consecutive year to address this major project conference. It is indeed an honor and a pleasure to address this august body and engage with like-minded people from a profession that I hold dearly and in which I have honed my skills as an engineer and as a techno-bureaucrat and as a policy advisor over these last few decades, from the late 1970s until now. I've had the rare opportunity to do so across several different portfolios, including housing, works, water, mining, as was mentioned earlier, transport, environment, climate change, and across several political administrations since the late 1970s. I guess old folks, let me be politically correct, more mature persons would conclude that I am no neophyte in the field of engineering, but the younger generations may yet look at me as a dinosaur. And of course, in the old days, when people saw dinosaurs, they were wondering if those animals were coming around to eat them, because the carnivorous ones, there are some of them who devoured human beings. Mr. Chairman, the theme of this year's conference, Engineering for the Future, Research and the Development for the Continued Growth of Jamaica, is an opportunity for reflection on how far we have come in the field of engineering, including engineering education, a time to assess the shifting landscape of an evolving vocation, and maybe more importantly, a time to reimagine the future of engineering in a world that has become more complex, more troubled, and at the same time, more advanced in science, technology, and engineering. The theme speaks to the continued relevance of a profession that has grown to include diverse branches of engineering. And in addition to the traditional branches, we are hearing about all kinds of branches of the profession that have assumed relevance because of today's technological and social development, biomedical engineering, aeronautical engineering, astronautic engineering, of course, environmental systems engineering, computer, software development engineering, among many, many others, as engineer asserts its place as one of the most relevant professions that the world has to contend with. Engineering education has also expanded, not just in terms of the field of study, but also in the number of educational institutions that are offering programs in Jamaica and the Caribbean, and indeed online. The expansion is not surprising given the relevance of the profession. Engineering touches every aspect of our lives. The skills are in high demand, as was mentioned earlier when the head of the school referred to the lack of capacity over there in NWA to implement the kind of programs that this country requires at this time. And this is not new. This has been something that has been ongoing for quite a while, and sometimes the lack of implementation or even the lack of planning, there were times when it was very constrained by the lack of resources. So we can finance says we can find 3 billion this year. So our planning is constrained to a 3 billion plan, although the needs might be a $10 billion needs. And sometimes it even makes us look inept and incompetent, but unfortunately, that's the nature of things. But we have seen changes over the years, and that is very refreshing, and I will touch that a little later. Innovation will always be needed to respond and anticipate the needs of society. And I'm going to ask you to just consider 2 examples of engineering innovations centuries ago that are still impacting the lives of people. And that is one of the things about engineering innovation. They are enduring. Some of them will be made obsolete by advancement in technology, but there are others that are very, very enduring. And even within them, changes takes place that make the original innovation even better and more efficient. One case in point is the creation of the electric light in 1879, way back in 1879 by Thomas Edison, and would have seen how that has evolved over the year. And Edison didn't really invent the scientific principle, because you put 2 electric wires together, they will spark and they will give you some light and heat, among other things. Electric shock could be a consequence as well. But the engineering that made it possible in a controlled environment, so you can switch it and it comes on, and then the research and development that have caused it to evolve from incandescent to fluorescent, and to nowadays LEDs and other forms of electroluminescence and other forms of development that have made even some of the technologies that we use, like touch screen and other things, possible, stemming from that single innovation at that time. Alexander Graham Bell created telephony in 1876. Once again, centuries ago, but the Bell Telephone Company has now developed into AT&T, a Fortune 500 company, a company that is among the largest producers of telecommunication services in the United States and indeed globally. And one of the things that have kept them relevant is because they have evolved over the years. So the telephony that was invented then represented the technology that was available then, but they have moved over the years with the technology to what it is now. Other inventions throughout the year are worth mentioning, and I can talk about many, many of them. I mentioned MRI, for instance. used in the medical field and in other fields to look at shapes and objects that we are not able to see with either with the naked eye or without that kind of technological enhancement. The World Wide Web, car braking system, water treatment systems, gas turbine, mobile data networking, and the silicon chip, use of semiconductors. The first time I went to the United States, I visited a lab at the University of Florida. A gentleman was there cutting silicon, slicing silicon into thin wafers. And his success was measured by how thin he could slice it, and also how consistent the slices could be. Because when he makes a slice, integrated circuit is going to be imprinted on those silicon wafers, and you want consistency so that every one of them will have the same properties, whether it be conductivity or resistivity, whatever it is, so that you get consistent, high precision quality. He was working with the technology available to him in those days. It was in 1981, so he had some kind of mechanical equipment to slice the silicon. Nowadays, you have lasers and all kind of high-tech equipment, and so specialized has been the development of semiconductors that any aberration in the supply chain or in even the supply of raw materials can cause shock waves across the world, as happened a couple of years ago when we begin to realize shortage in chips were in fact impacting the automobile and other industries, even consumer appliances that requires that uses a lot of these electronic chips. But the example of the researcher in that little lab at the University of Florida that I experienced was really inspiring, because it tells you, first of all, we are in a world of integration. Many different parts come together to make some of the products that are commonplace now. But it required a lot of research, a lot of innovation, and a lot of persistence. That little lab was not comfortable. The gentleman was there working, and he was not directly producing any of the fancy end products that would arrive from his research. But there were many like him. One cocoa full basket is a word that we say here in Jamaica, and we can all play our part in ensuring that we innovate, that we develop, and that we go from strength to strength in terms of contributing to industries. All these engineering innovations have been profoundly altering sectors and industry, quality of life in both developed and developing countries, and in travel, communications, and trade. It is indeed an honor and a privilege to address, I'm backtracking. In preparing this presentation, I reflect on how the pickings or the opportunities were when I started my studies. In those days, you either had to go to Trinidad or to go to some expensive universities up north. Today, you can still go to Trinidad, but there are options here in Jamaica and in the Caribbean, Caribbean Maritime University, University of the West Indies Mona campus, here at the University of Technology, and indeed online. There are post-secondary school programs at HART, NTSA, NSTA, and community colleges that prepare young people for a transition to university programs. Not only have we seen more options, but attitudes for the profession have changed. This change is evident in the demand for engineers in both public and private sector. And there are interesting developments, even the recent public sector compensation review, where there, at long last, has been some kind of recognition for the service of engineers. And it showed up when the process was finished, we had many engineers now earning more than the people who supervised them in some of the public sector, because some of the challenges that we've had in the past were addressed in that particular review. Not fully, but we have come some ways and we are moving forward. I remembered when I was seeking a job. I'm not sure if seeking a job was the right thing, because in those days, as I said, engineers virtually could choose where you work. So I just finished my master's. I went to the University of Guelph. I did water resources, engineering, focusing on irrigation systems and all of that. And I came back to Jamaica and I heard a gentleman, Mr. Eli Tisona, talking about growing up winter vegetables in Jamaica and the possibilities and what they have been able to do in Israel and what have you and what have you. And I heard the then Prime Minister also talking about the program. And there was a company called Agro 21. So I contacted one of my colleagues. He had just completed his degree in agricultural engineering. We said, let us go down to Agro 21 because they need us. We virtually figured out our job description in our head. And we went down to Agro 21. Only to be told by the program manager at the time that we don't need engineers. All we need is some agronomists. We have 5 sections of the project, and we want 1 agronomist for each section. We already have 2, and we're looking for 3 more. You know, it was a jaw-dropping experience for us, because I don't know how they were going to implement that program. Based on what I heard from the Prime Minister, based on what I heard from the Israeli gentleman, how we're going to implement without some serious engineering input, given the kind of infrastructure we had at the time. Anyway, we left. He went his separate way. I think he went to Jamaica Broilers. I went to UDC. And while working there, after a while, felt maybe it's time to move on and start to look again. And I saw a company, KPMG Pete Marwick, advertise a position. He said, our client so and so and so. And when he described, you know, the description sounded like something that I could take on. So I decided to apply. And when I went there after a 2-hour long interview, psychometric testing, what have you, at the end of the day, he said, our client is Agro 21 Corporation. They were looking for project engineer. And I found it very, very amusing, because I was told just less than 2 years ago that they didn't need engineers. But when I went there, I realized they actually had a chief engineer, and there was 1 engineer for each of these segments that they had mentioned, and I was one of them. I was selected as one of them. And I worked there until Agro 21 virtually morphed into the National Irrigation Commission, which was, in a sense, the engineering arm. Started off with us, the same team that went to Agro 21, and the rest, in terms of National Irrigation Commission, is history. So sometimes a lack of understanding of the skills needed can work to the detriment of the organization and indeed to the detriment of the country. But thank goodness we were able to make good after more than 18 months of delay. I remember when I told my boss at the UDC, I'm going to Agro 21. He said, no, Agro 21 is nothing. They have been sitting down there for all this time and they have not been able to do anything. And we were able to go and at least had the opportunity to make a difference. And I think part of the lack of recognition at that level, because when the chief of engineer at the Urban Development Corporation, a very responsible organization in the engineering discipline, we had a staff there of maybe 5 or 6 engineers. Some of them have grown to become heads of agencies and serious contributors to development of our country. One of my co-workers, for instance, was Mr. Ivan Anderson, who later became head of the NWA when we established it, and head of NROC, and head of Trans-Jamaica Highways. So when that recognition is not there, that happens primarily because the organization that was established did not equip itself fully to be able to carry out its mandate so that it can be recognized. Very few professions had such profound impact on every important aspect of life and such undeniable inspiration to the human race. That is the first human. Think about this. The first human entered space in 1961. Man walked on the moon in 1969. Space tourism started in 2001 when American businessman, engineer Dennis Tito became the first space tourist to travel into space. But nowadays, the space tourism has become, in a sense, commonplace. But of course, all of these are possible because of the beloved discipline that we call engineering. Consider too, mechanical engineer Charles Babbage, and many of you would have heard about him, who was considered the father of the computer, even though some people think it might be Turing, originated the concept of a digital programmable machine in 1822. The first personal computer, known as Micral N, was developed in 1973, centuries after. The internet, but of course, in between 1822 and then, some engineers and scientists got together and did construct Mr. Babbage's machine. Could feel half of this room. The internet in 1983 was developed, the World Wide Web in 1989, and today the world is talking about robotics, autonomous vehicles, artificial intelligence, generative AI such as ChatGPT and Gemini, which are heralding the coming of superhuman artificial intelligence. The last one is probably the most controversial, said to be able to read minds, supercomputers that can improve themselves over time. And these are all developments, of course, that is exciting in the engineering fraternity. And the engineers are not overawed by them because engineers are integral to the development and indeed the maintenance of these systems. But I think it is also saying that things are changing and we are not able to predict the outcomes because things are changing so rapidly and features, power, are also developing at a rapid pace. I bumped into a book a couple days ago called This Is It. The it meant information technology. So this is IT, if you want to say it that way. It was written about 1981, and I was looking through. It was replete with pictures. Pictures of card reader, pictures of this, pictures of various components of what was then viewed as information technology. And I'm saying any of my children or grandchildren look at that book today would not, most certainly not recognize that it is information technology that book was talking about because of the obsolescence of so many of those pictures and illustrations that were in the book. The soaring heights of engineering feats, computational genius and capacity, scientific eminence have led to cultural transformation. How we teach, how we learn, how we grow our food, how we manufacture, and one can talk about 3D printing, for instance. Medicine, security, construction, how we use, store, and distribute energy, build water systems, how we communicate, travel, and even how we fight wars. These epic achievements are rightly celebrated. Countries claim bragging rights and epistemic communities memorize iconic, imaginative inventors. Indeed, inventors that have done tremendous things, invented many, many useful things, are idolized in their communities. Yet, in the shadow of such mind-boggling successes are the gut-wrenching features of the human race. The 2022 United Nations Global Nutrition Report estimated that the number of people affected by hunger is over 768 million. 3.1 billion persons cannot afford a healthy diet. The World Bank puts the figure of living in poverty at 712 million, while World Health Organization, WHO, estimated that 3.6 billion people live in areas that are susceptible to climate change. The moral dilemma we face is this: must we accept the glory for these other phenomenal achievements, but ignore the negative impacts of these achievements? Whose responsibility is to find the solutions to man-made climate change? The pollution from cars we design, the mass displacement, deaths, hunger, disease, modern-day slavery that are repercussions of wars that are fought with our inventions, our machines, from guns, bombs, fighter jets. What of the deforestation resulting from bigger and faster machines that destroy our forest? These are some of the things we have to consider as engineers going into the field, wanting to live in a sustainable world, because man has a destructive tendency in upsetting the balance of our sustainable environment. So, those are food for thoughts, really, and I'm sure we and the university would cover some of these issues in their normal course of things, and also provide insights to some of our students who are going to be doing research in their postgraduate studies. Some of us may well argue that we in Jamaica are just a small fish in a big pond, and that our work could not possibly scale to have global impact. I will revisit that argument later in the presentation, but I want to look at some contributions of engineering to the modernization and transformation of Jamaica's economy. I'm looking at especially during the period when I was active in the public service, because that gave me the opportunity to have first-hand sight of most of the public sector development projects, whether they be airports improvement, port expansion, road expansion, modernization and transformation in terms of including and inviting private sector participation, and so forth and so forth. Indeed, I was coming in this morning, and I left central Manchester at about 7:10. By 8 o'clock, I was at 6 Mile. That's 90 kilometers in 50 minutes. And then from 8 o'clock to here, maybe 10 kilometers, I don't know, it took me, it's almost like 90 kilometers to that amount of time, but the 10 kilometers from 6 miles to here took me much longer than the 50 minutes. In fact, it took me about 70 minutes to get here. So the private sector participation was one of the innovations of government to allow private funds to come into doing the kind of investment that the little funds that trickle from the Ministry of Finance on a year-to-year basis would not have been able to do. And by doing so, of course, we got the opportunity for interacting with our international investors, participating of our engineers in those kind of projects, both in the construction and the maintenance. Sometimes we don't appreciate the history, and I'm just going to refresh us a little bit on some of the projects. I mentioned generally, but I'm going to focus on a few of them. Well, since 1998, the government got very ambitious in really trying to improve our infrastructure. It was felt at the time that we were kind of backward. In 1998, I became responsible for transportation in the Ministry of Transport and Works. And I sat in the plane one day and hear the pilot announcing when the plane landed in Kingston. Remember now, this is Jamaica, and you know, you must be very careful when you walk down the step, and you must also look out. We expect some showers. He was warning that we might get wet walking from the plane to the terminal building. And these were the kind of things that we had to encounter. Montego Bay International was no different. The plane stops, you let down a step that goes down, and you walk down the step, and you walk to the terminal building. Air Jamaica had to fight many, many cases and settled many clients, our customers, because they got injured while they were walking down that step. So the development, the government then anchored the development on two grounds. We're going to privatize, and we're going to see what we can do with Norman Manley. So those were some of the things that would have spurred the government on to dealing with major infrastructural development. So the privatization saw Montego Bay being developed. And then, so much was the growth that it had already outlived its development. It needs major expansion to the terminal as we speak, but it's a far cry from what it was then. And so, similarly for Norman Manley, although COVID would have slowed them down a little bit, but similarly for the North Coast, the highway from Negril to Port Antonio was a two-lane carriageway, not very safe and not very good. And of course, there was a little team working behind the scene about toll road. We saw also the expansion of the port down there at Garden Key over in the Kingston Harbor. The expansion of the runway. So it's not just a terminal building at the airport, but the improvement to the runway. And you'll remember the controversy of the runway at Norman Manley when the contractor imported 150,000 tons of aggregate from Canada to build that runway. Improvement of the runway and expansion of the runway over in Montego Bay as well. So all of these were necessary things to ensure that some of the transformation and transition that was required to grow our economy were taking place. So from 1998, and still ongoing, we have the South Coast Highway being built as we speak. We have the Montego Bay bypass being built as we speak. And these are very expensive and far-reaching projects. But I'm going to talk to you a little bit about the North Coast Highway. That was a project that extends from Negril to Port Antonio. It ultimately cost somewhere in the region of $400 million US. Those numbers were unheard of when we started. When we started, it was a little Japanese funded project for $23 million US to do minor improvements along the way as we go along. But ultimately, it was being realized that the scope had to creep to meet the real requirements. And we had to use creative ways to do it. So we eventually got funding from the Japanese. We just focused the Japanese money on segment 1. Ocho Rios, Negril to Montego Bay. Then the IDB chipped in with segment 2, Montego Bay to Ocho Rios. And finally, the EU, European Union, chipped in with funds for segment 3, Ocho Rios, and that was grant, by the way. Ocho Rios to Port Antonio. And that was how we were able to get those works going during the latter part of the last, let me say, century into this century. So at the end of the day, we had this 300-kilometer corridor from from Negril in the west over to Port Antonio in the east. And its impact on the tourism industry is still being felt, a positive impact. Lots and lots of investment from the Spaniards, Rio and Palmyra, among others, that built hundreds, maybe thousands of hotel rooms along the corridor. But from an engineering perspective, what is very, very interesting was that we were able to win an international award for that project. Segment 2 of the North Coast Highway Improvement Project, it opened in 2006, which ran from Montego Bay to Ocho Rios, won 2 international awards at the 2009 Iowa Engineering Conference in Des Moines. The project received the first place overall in the Grand Conceptor Award category and the Grand Place Award for Engineering Excellence. And it was a proud moment when yours truly, along with the CEO of the National Works Agency, then went to Des Moines in Iowa to mount that podium and collect that award. The Highway 2000, I'm moving on now, called upon local and international engineering expertise, our finest minds in contract law, project management, negotiations to bring fruition to Jamaica's first toll road and the largest infrastructure project in the English-speaking Caribbean at the time, and that was the East-West Corridor. And that was quickly overtaken by the North-South Corridor, where it was built at roughly twice the cost of the East-West Corridor. And then that first East-West Corridor had 50 kilometers of tolled motorway, but that would have been tripled now with the North-South and with the extension into Williamsfield. We don't call extension to Williamsfield tolled as yet, but definitely there is a toll collector coming your way if you are traveling from Maypen to Williamsfield free at the moment, and they'll be coming very, very soon. But Trans-Jamaica, which took over from the consortium of investors and finally became publicly listed on the Jamaican Stock Exchange, is now owned by Jamaicans, and it is doing very well. And I think it's going to be doing even better as we expand the toll road network in our country. And I'm going to mention just one or two others. I can't mention all of them. We only have a limited amount of time. And I'm available to come back sometimes in the future to talk about some of these things. Because the engineering experience has been, bittersweet, but sometimes when you really hear the story, you understand at the end why some people get the glory and maybe others get battered. But the Rio Cobre Dam is the next one I want to mention, because, as I said, I worked at Agro 21. I ended up with National Irrigation Commission, and it was around that time, in 1991, that the dam itself, that was built from 1876, completed in 1876, the dam collapsed. That dam was intended to serve over 30,000 acres of land to the south with irrigation water. So it diverted water from the Rio Cobre River into a canal network that went as far as down towards Old Harbor. One branch went. One branch came as far out to Caymanas, out on the Mandela Highway. and several other branches that serve the entire area with water, primarily at the time for the growth of sugarcane. But when that crop diversification stroke irrigation project came about, that I mentioned earlier down there at Agro 21, the Rio Cobre was to play a significant role. They had already started the process at Spring Plains in Clarendon. High costs and various other factors would have caused that to stall. But here you have gravity-fed water from the Rio Cobre that would feed the area and produce the desired result. So the dam collapsed in 1991. So no water was getting down into the area. And in addition to that, the dam produced water for domestic purposes. To the Water Commission, there's a pumping station down there, down near to Spanish Town, that would have been supplying domestic water. So when the dam collapsed, it was a major catastrophe at the time. But the engineers at the National Irrigation Commission got together, secured funding, and in 1995, the dam was reconstructed totally. You would have looked at the material of the original construction. They didn't have Portland cement, apparently in those days. It's a lot of stone with some bonding material in between, and that was how the original dam was constructed. But it survived. It survived over 115 years. And it survived some very, very treacherous situations. Flood waters, 20 cubic meters per second, flowing above that dam over these decades. And it survived until it had to be reconstructed. The reconstruction required a lot of rigorous studies. Our engineers had to look, was the dam located at the right place in the first instance? Is it wise to either raise the level or move the location? All studies found that the dam was at the right place. It was right at the right place where the hydraulics would ensure that the water, most of the water, is diverted efficiently. The size of the canal and all of that, they were more or less correct. We decided, however, that like the main canal, which was unlined, should be lined, and some of the other canals that were unlined would be lined and all of that. But on the reconstruction, the material would be modernized in a sense. So we're using reinforced concrete, talking about 4,000 PSI concrete. Not so much reinforced. The reinforcement is there mostly for the prevention of cracking and all of that. It's really mass concrete. And one of the things that we did was, instead of just snuggle up in a corner with our consultants and go ahead and do the project, we engaged the Jamaica Institution of Engineering. So we had a one-day engagement where they came, they visited the dam, the designers, presented to them, and we have to ensure, because whatever we are designing or doing should be able to stand up to scrutiny and should be able to be reviewed by our peers. It's because the concern would have been there that we might hurry up and build something out of pressure from the stakeholders and build something quickly that did not stand up to scrutiny. So the JIE was very, very present, and they understood what was happening. They asked questions. Questions were answered. They put their own insights into things, and eventually we were able to reopen the dam in 1995. Sounds like almost 30 years ago. So far, so good, knock on wood. And it is serving a tremendous purpose. In fact, the pressure now is more for domestic water than for irrigation water, because a lot of the lands that the dam was supposed to irrigate have now gone into housing. And these are some of the policy issues and policy decisions faced by government. Because here we have the dormitory community of Portmore, and still there's a tremendous deficiency in housing. The Prime Minister announced few years ago about 70,000 houses in 3 years. It may stretch now to 5 years, but the moment a housing scheme starts being built by the Housing Agency of Jamaica, there's a tremendous amount of demand. When I had housing just a couple of years ago, we had a situation where Catherine Estate, 1,600 units. Initially, they cut off the application when it reached 7,500. So 7,000 people applying for 1,600. And you know, in HAJ, the application means from eligible people. They don't count application from people who are not eligible. So the moment you apply for a HAJ unit, you have to get, whether from NHT or from your employer, some kind of letter that shows your eligibility. So there are 7,000 odd people sitting down waiting for the 1,600 units. But there are others. But this one was of particular importance because they are small and they appeal to inexperienced or young workers in the workplace. The 7 million and the 8 million and the 9 million category of workers. So that expansion is important, but it also has an impact on the Rio Cobre, because now the Water Commission is taking more water from Rio Cobre for domestic purposes, while the demand for irrigation purposes seemingly is less. But I think there's a need for more investment now in more intensive agriculture, to use less land space and to use the water as efficiently as possible so that we can produce and generate. And we can, in a sense, it can be a win-win situation where you get the housing, you get the water, and you get also the agricultural development. The other one, I must tell you, at the time, the cost of rebuilding the dam was $275 million. I think it would have translated maybe to about 60 or 70 million US, based on the exchange rate at the time. The next one we're going to look at very, very quickly is the Soapberry. And that's the Soapberry project. But before we look at Soapberry, I just want to mention two construction features associated with the Rio Cobre River. The Flat Bridge, infamous for its many horror stories, dopey stories, rescue stories, was built in 1774, with the original structure said to be built in 1724. Edward Long, in his publication History of Jamaica, described the bridge as being made of planks on frames of timberwork, which rest on 2 piers and 2 buttresses. Friend of mine, my chief engineer at Agro 21, says the first bridge he's seeing where the pier is wider than the path for the water to flow. But I guess it was the appropriateness of the engineering at the time. Less known, but of some engineering significance, is the old iron bridge in Spanish Town. And you would have known that the engineer at JIE, for instance, has taken a special interest in ensuring that that bridge is preserved and maintained. It was designed by English engineer Thomas Wilson, constructed by the firm Samuel Walker and Company in 1800, casted by iron elements in Rotterdam, South Netherlands. The bridge is 82 feet long and 15 feet wide. The bridge was dismantled and shipped to England, then to Jamaica, where it arrived in 1801, opened in 1802. Considered the oldest of its kind in the Western Hemisphere, it was declared a national monument by the Jamaica National Heritage Trust, and at one time was placed on the UNESCO list of endangered world site. And it is only fitting, as I said, that the engineering fraternity headed by the JIE, had taken a strong interest in the bridge. I remember days when Mr. Engineer Leo Lawson and others would appeal to the ministry for some funds to assist with the preservation of that structure. Soapberry now is a 225,000 cubic meters per day water treatment facility that was built to replace smaller treatment plants serving Kingston. One of the major objectives, of course, was also to reduce the discharge of effluent into the Kingston Harbor. The plant is still not fully utilized, as all the conveyance of sewage into the plant has not been built out, but it has been working very, very efficiently and have been serving its purpose. And with that plant, there is hope for the Kingston Harbor. These projects required significant engineering input, but what is common across the projects is the transformative impact across multiple sectors and how economic and social activity is influenced strongly through the multiplier effect. Job creation, reduction in poverty, expansion in economic activities, wealth creation, environmental sustainability. All of these have that kind of impact, and indeed, we must always be aware of the sustainability of the projects that we develop over the years. I'm now going to touch a little bit on research and the role of research. Based on our theme, we have to recognize that it is research that is going to take us from where we are to where we want to be, and to open up some of the opportunities and to challenge the practitioners and indeed the students in moving forward. A profession with the capacity to have fundamental ability to alter the ecosystem deserves to be supported by robust research architecture. I would like to advance the argument that there is need to scale up engineering research, not just at UTEC, but also in other engineering schools across the Caribbean. To define the future of Caribbean engineering and to create big regional projects designed to address the defects of the historical structural inequalities and inherent disadvantages faced by Caribbean economies. Persistent poverty at 30% of the population in the region suggests that we are failing in the 17 sustainable development goals of the United Nations. As engineers, we have a responsibility to respond to this regional agenda by seeking or helping to find solutions to this pressing priority. The multidimensional nature of the causes of poverty opens up research opportunities for the regional engineering community. Let us examine some areas where policy and big projects could be informed by engineering research. Take access to affordable shelter, which I mentioned earlier. One in 3 families live in inadequate shelter in Latin America and the Caribbean, according to an IDB study on housing deficit in the region. Research in low-cost recycling material suitable for climate and with the ability to withstand natural disaster could provide viable solution for shelters. And I'm not saying that research are not being done. Maybe we are saying opportunity exists for more. Partnerships with Rotterdam, Southern Netherlands. Sorry, I'm going back on myself. Partnership with governments and not-for-profit organizations operating in the region, but also in other jurisdictions, could help to scale projects region-wide. A robust research agenda could include the production of scholarly papers, studies, and articles addressing everyday problems of people, hosting regional and international conferences, panel discussions, engaging in policy discussions, preparing policy brief and partnerships with research centers and projects in other jurisdictions. There is ongoing debate about artificial intelligence and superhuman artificial intelligence, to which our thought leaders in the engineering field could lend some voices. The rhetoric of some experts, such as Turing Award winner Johanna Bengio, posits the ideation of superhuman systems outperforming humans in numerous tasks. This concept is embraced by big business, as evidenced in IBM Artificial General Intelligence, AGI, focusing research program, Strong AI. AGI would require an intelligence equal to humans. It would have a self-aware consciousness that has the ability to solve problems, learn, plan for the future. Strong AI aims to create intelligent machines that are indistinguishable from the human mind. And you know, we can stretch our imaginations all we want. I mean, AI is with us. They might come when the client, instead of coming to an engineer, sit before a humanoid, say, I want to build a facility at this location, upload the geographical or geospatial information for the location, point out the requirements, and the AI simply searches up, look at the regulatory rules, and come up with a design, maybe even complete with drawings. So these are things that are happening that are challenging us, challenging our minds, so that we are aware that there are many, many permutations that can take place in this field. And the sky is the limit, as they say. But regardless, of course, engineers are always involved in that. I am going to take a quick look at the kind of expenditures that are going on in research and what is being spent on artificial intelligence. Global AI investment reached $154 billion in 2023. It's estimated that this figure will reach $200 billion by 2025. These are big companies that are investing in some of these AI architecture. I am just going to touch quickly at the building of capacities at the university level. Regional universities should carry out immediate assessment and review of engineering education. We have already established that engineering education is of such importance that we really, really need to expand to build the capacities. This head of school pointed out earlier again, and that is a critical juncture that we have reached. We need to build capacity. To leverage resources, strengthen cooperation, and deepen collaboration, to decide on a few big projects, to establish frameworks for complementary and not competing approaches. Some actions that may benefit us include establishing a chair of engineering at each university with a school of engineering to provide strategic guidance to the development of a Caribbean engineering ethos that has relevance to the aspiration of the region. A priority of the apex of academic engineering would be strengthening of institutional capacities, exploring cutting-edge advances in engineering development of progressive curricula, exploring allied fields of study, advancing more structured engagements with the regional private sector, development of partners and NGO and community-based organizations across the region. Partnership is very important. Secure partnership through twinning with engineering research centers and engineering schools in other economies. Establish exchange programs for the students and faculty and explore visiting professorships. I have no doubt that some of these are happening already, but it may well be that the opportunity now exists even to expand. One of the innovative things that I've learned of is the establishment of Engineers Without Borders, similar to the Canada and UK bodies. Engineers Without Borders UK projects include the design of Ecosan toilets for Rwanda in an effort to tackle waste and create fertilizer, in the development of an app to map informal settlements in a city in India. That's a second initiative. A considerable strength of the Engineers Without Borders is the alliance that are made with NGOs such as Help Poverty Action in the UK and Shelter Associate in Maharashtra, India. So we do have that kind of opportunity to develop. And just a quote from Katie Cresswell, Head of Learning, Research and Innovation of Engineers Without Borders, is worth noting. We want all engineers to be able to understand, consider, and address the impact of engineering decisions on the social, environmental, economic, and political dimensions of the local and global context. Take decisions in line with sustainable development values and implement solutions that have a genuine benefit for the society. For this to happen, engineers need to be good at understanding people as well as understanding the environmental and technological principles. We refer to this as the idea of becoming a globally responsible engineer. And last in this section, to establish strong awareness raising architectures, including annual regional conferences, engineering expos and symposia, annual lectures, and publication of research work. And of course, public relations, communications. We don't like to use those terms among engineers, but that's also part of the mix, including where necessary or where applicable to leverage social media. As I wind up, and of course in this short presentation, there are many things that I could have included, I ought to, but can't capture everything in one. We haven't spoken about gender as yet, and there are other matters that I have not touched on. But I will just wind up by dealing with ethics, engineering ethics. Ethics in engineering. Does it matter? And I say it also from a background of having coming into the public service at the time where that was a great concern, especially one of the departments that I had inherited and managed to play a role in transforming. That was the Public Works Department of the then Ministry of Works. We have devoted a considerable amount of time discussing scope, complexities, and ubiquitous nature of the field of engineering, touching every aspect of life. We build bridges, roads, cars, machines that can create disasters, disrupt life, dismantle economic systems, and destroy democracy. The opportunities for corruption are endless. Having an ethical code by which you live and work starts with you. Every decent human being should have a place within their soul that is inaccessible to dishonesty and inviolable. Well, I repeat that one. Every decent human being should have a place within their soul that is inaccessible to dishonesty and that is inviolable. This is who you should be as a human being. You may work with a company with no ethical code, neither written nor practiced, where integrity, honesty, and moral characters are not valued. Your decision to leave or stay will be informed by your personal sense of values. I will tell you this, you will never be a good engineer if you lack integrity. Why? You will accept, or you might accept bribes to produce a good report on a project that you know has fundamental flaws. You might cut corners so the quality of work will not withstand scrutiny. And you know, these are some of the things that could compromise the integrity of an engineer. If you work in the public sector, you may be involved in providing technical assessment for proposals valued millions, even billions of dollars. Do not underestimate the corrosive influence of corruption and the persistence of persons to buy a favorite assessment. You might think everybody is doing it and benefiting. Why should I be left behind? Even your own colleagues may laugh at you, calling you derogatory names and making life uncomfortable for you. And going into the workplace, this is a real threat. There are times when you are told by some superior that this is the person I want to get that contract, or this is the person who we want to buy whatever from. And when you know from an engineering perspective that that product is inferior to this one, and your assessment is saying that way, you have to know how to navigate and let your integrity be your guide at all times. Many persons choose to study engineering because it's a respectable profession, has a prospect of good income. Some genuinely want to make a difference. None of these motives are inherently bad. You can pursue wealth and make a difference. The danger of being single-minded about personal ambition is that you become inward-looking, self-absorbed, and can be detrimental to innovation, creativity, and critical thinking. You could be constrained by the narrowness of thinking. You abandon lifelong learning, and you have difficulty to scale beyond self-interest. Most important of all, the fundamental outlook of the engineer must be futuristic, a capacity that you might not possess. In short, if you don't possess that capacity, you are not an engineer. Royal Academy of Engineers and the Engineering Council has identified the cardinal principles that they believe should guide the engineers and technicians in achieving the high ideals of the professional life, which express beliefs and values of the profession. The first one is accuracy and vigor. And I'm winding down. I see Madam Moderator nearby. I thought I would have gotten the extra half hour that the president did not take, but I'm going to relieve. Accuracy and vigor. Secondly, honesty and integrity. Thirdly, respect for life, law, and the public good. And fourthly, responsible leadership. There is a strong argument for strengthening, in concluding, regional capacities and capabilities through a repositioning of research as a strategic investment in academia with benefits to government, big business, communities, and across the Caribbean region. We have argued for the leveraging of resources and develop jurisdictions, the establishment of effective partnerships through the twinning of facilities and the expansion of engineering education to secure the region's engineering future. Brothers and sisters, I just encourage you to embrace lifelong learning. Be outward looking. Have a vision that is bigger than your own self-interest, and do not forget that creativity, critical thinking, and innovation are the hallmarks of an engineer. Once again, let me congratulate you on the hosting of this conference, and I look forward to seeing the results of your deliberations. Thank you.
Thank you very much, Dr. Hales. We have learned quite a lot. But one of the things that I hope you have all paid attention to, closer to the end of his presentation, was ethics. All right? Ethics in engineering. I'm looking at all of you, and I am hoping that you live up to that standard, that ethical standard that all engineers must, not should, but must live up to. Remember, as engineers, we deal with people's lives, all right? Not, my students know that I tell them, not one at a time, like doctors. We look at everybody in our community, so we have to be very careful. At this time, I must acknowledge the presence of our president, Dr. Kevin Brown, but before he comes up, I'm going to ask Mrs. Nicole Booth Thompson to come up and just give a word of thanks.
Thank you. Thank you, Dr. Chambers. Good morning, everyone. Okay, Dr. Hales, this is for you. Thank you so much for being here today, and understand that you were dearly missed last year. Okay, the trip down memory lane with you this morning spoke to us of where we're coming from as engineers, where we are today, and with technology and innovation, what to expect in the future. You drove home the saying, if you fail to plan, you plan to fail, right? We all remember that? And so tomorrow, we'll see our students actually reaping the fruits of their labor from their presentations, right? The benefits and support to engineers that you spoke to are welcome, not to mention the expectations, right, that we'll all strive to live up to as engineers. So thanks again so much for being here. And on behalf of the School of Engineering, we want to present you this small token of appreciation. And really and truly hope you enjoy. You'll hold the mic? Okay. Pardon? It's 2 gifts, you know, so. Okay, so you want to be over here? All right. He's going to take that to me. So shake with left. There you go.
All right, so thank you very much, Dr. Hales. At this time, I'm going to ask our president, Dr. Kevin Brown, to address us. I know he has a very busy schedule, but I thank you for being here.
Thank you, Dr. Chambers. I see you're now, you have a new responsibility role as Master of Ceremonies for Engineering Symposiums and Conferences. So thank you. Let me start by acknowledging our special guest, Dr. Hales. Dr. Hales has a rich engineering background, former permanent secretary in the Ministry of Transportation. I don't know what he's doing these days. Perhaps a man for hire to solving all engineering problems. But I want to thank you Dr. Hales, for your address. And I want to speak to that ethics topic that you mentioned. It's very important that all our students in engineering leave here with a strong sense of ethics and personal values. Because if you didn't hear what Dr. Teresa said, everything you do as an engineer affects people. People. If you don't get the calculations right in this building and something happens and it starts to shake, people become casualties. When I was working in the aerospace industry, every time there was an incident on an aircraft, all of us in the office would rush to the TV in the office to see if it was one of our engines. All right? Because we know that our engines are carrying people 40,000 miles up there, no mechanic, right? No rescue service, so we have to be reliable. And so ethics was very important. If we were designing an engine and you found out that your calculation was wrong, you had to put your hand up and say, hey, stop. It's wrong, we have to go again, right? And sometimes you'd make very expensive mistakes, millions of dollars in the aerospace industry, and you have to go again. So ethics, all of you must go out there with strong ethics. Strong ethics. Do the right thing. Put your hand up if you make a mistake, right? That's a UTech engineer. So thank you, Dr. Hales, for reminding us how important it is for engineers, more than anyone else, to be ethical. Let me also acknowledge Dean Thorpe, head of school, O'Neill Josephs. Vaughn Alexander, who's smiling because, my gosh, what a major project conference this is. When I was handed this magazine, I was most impressed and really pleased with how Vaughn and the rest of the School of Engineering team have made this major project conference into something special. When I was an engineering student over 2 decades ago, we had major project presentations, and they were very different. Less so on posters, more so on showing you what we built. It was a very practical design and make approach. I assume there is still some making today, and I'm sure I'm being told I'll see some of what you've built or your prototypes. But the emphasis many years ago was on ensuring that you design and made something, right? So you could always see the practical outcome of it. I don't think that emphasis has changed, but of course, engineering has changed. Engineering is a digital sport. When I was going to technical high school, T square, set square, paper, pencil. Well, I can tell you that engineering has moved on. It's all being done via computer. And the expectation is that as engineers, not only must you know how to create your 3D models, you must also know how to assess them structurally. So you need some understanding of finite element analysis for those who are doing mechanical engineering, to stress your models, to make sure they won't break, make sure they're within the elastic limits, and so on. I see lots of Arduino-based projects inside here, right? So engineering has changed, and we have to change. Our faculty keep having to upgrade themselves. We have to upgrade our facilities. And you as students have to be lifelong learners. So you have finished your degree. It will probably be relevant for about 5 years because technology is changing so quickly. So I look forward to seeing some of these faces back here at UTech, upgrading yourself, doing a master's, doing a short course, continuing to learn and developing yourself. So don't think that, yes, I get my degree and I've got a job and that's where it ends, right? You're going to have to continue working. I wanted to say a few words about where I'd like to see engineering go next. You are at Jamaica's STEM University. If you didn't know that, make sure you know that, and you claim it and you say it. You're at Jamaica's premier STEM University. That's what we do. That's what we've been doing for 65 years, producing quality engineering graduates. But we need more. The Prime Minister keeps saying we need more engineers. And that's the challenge that we've been set. To align ourselves with the government's ambitions, this university has to produce more engineering graduates. And we will have to go out there and not only find the students to matriculate, but also grow, because we'll need more staff, more facilities, right? So it's a big challenge. And the challenge starts before UTech, because we need the students with the appropriate maths and other qualifications to enter the institution and to do well. We need to increase our completion rate. Too many of you don't make it. Look around. How many of you have friends that you made in first year who, when you look around, they're not here? We have to improve on our retention rate. And we have to make sure that you complete. So one of the things I'm discussing now with the leadership team is that we have to introduce a program that supports students. Examples include having final year students, the best and the brightest of you, becoming tutors and being paid perhaps under earn and study to tutor your first year friends who may be struggling with subjects. We will have to improve on advisement. And I know Professor Thorpe wants to build out an advisement center in the faculty, and academics will have to participate. It's part of their job. But we also need to get dedicated advisors as well, who just do advisement full time. So when you as a student enter UTech, you can find someone to talk to about your course, about your career aspirations. We also have the big challenge of upgrading our facilities. And this is where I'm going to turn to my friends at Huawei, my friends at JPS, my friends in industry who love our graduates. And I'm saying to them that if you want to see this university grow, and if you want to see Jamaica become a better country tomorrow, you need to support this institution with re-equipping our labs. So I want to see a relaunch of the JPS lab. JPS is here, so I'm looking right at him. I want to see a relaunch of the JPS lab with the latest and greatest equipment in there. And let us tell the world what JPS has done. The JPS lab at UTech, the Huawei lab, we're working on that. And all the other industries have a space here waiting for them. Because we are working for you. We're delivering your workforce. Your workforce. So you have to come and participate. Don't just sit on an advisory board telling us you want the curriculum to say ABC. Put your money where your mouth is. So it has to be a partnership. And the government of Jamaica, despite the vision, is underfunding this university. But we will have to diversify our income, and that's why I'm calling on our partners in the private sector, because they are the ones who are employing you. For those of you who may want to migrate, I can't stop you. I did that as well. But I want to encourage you that as you make your migration plans, which may include upgrading your educational qualifications, don't forget your country. And be an ambassador. Be an ambassador when you go over there, wherever you go. And strive for excellence. Because I know that UTech worked hard, right? But I tell you, when you enter the next institution, you'll be thinking, wow, I was well prepared. The pain and the sweat at UTech prepared me to excel elsewhere. So we want you to go out there and be excellent. But once you have excelled overseas, do not forget your country. Do not forget your university. I want to see some of you coming back and donating. When you get that big job at NASA, some of you, come back and say, Professor Thorpe, here's a check. If you don't help your university, no one else will. And let me say this, UTech is not perfect, but the commitment you have from me and the leadership team, both across the university and in your faculty, is to improve the student experience, is to make sure that UTech is truly student-centered, so that when you leave this institution, you can leave feeling like you were treated well. The challenge for us is to improve our processes. We have too many manual processes. Anyone ever tried to add, drop a module? Okay, let's not start. I know the problems, and we're going to work on them. Too many manual systems in a technological institution. But this is due to underfunding and underinvestment. So those things have to change. We also want to make sure that your capstone projects become research projects. So we want to develop our undergraduate research programs so that more of you will want to pursue masters and PhDs. These are things we will have to work on. Make your capstone projects more research orientated. Some of them are, many of them are. I'm quite impressed with what I see here. So how do we convert more of these into research projects that we can take further? And finally, we have a strong culture of cooperative education. Putting you out there to go and get 500 hours of industrial experience. And we will continue to do that because we believe that we are creating graduates for industry. And we want you to have that experience before you leave the institution. So we will continue to grow that aspect of the engineering program. So in the future, my friends, students, faculty, right now, the College of Business and Management is the largest school. But if we are to truly claim that we are a STEM institution, this school, School of Engineering, School of Computing, should be the largest by numbers. So we have to, I love my business friends and students, but if we are STEM, then this faculty should be the largest. All right? So that is a challenge that we are faced with. And I believe that the faculty are committed, and I know that you students have done your best. So let me just thank you for all the hard work you've done to get this far. Congratulate you on your capstone projects. I will have to leave after speaking, but I'll come back at lunchtime to have a tour of what you've done. And I wish you all the best in your future endeavors. All right? Just be confident and know that UTech has prepared you. And JPS is here if you need a job. Huawei is over there. So go and talk to them as well, right? You have to be confident and speak what you want. All right, thank you so much, and well done again to everyone.
Thank you, Dr. Brown. We all have to be so proud of him. I think you're the second president who is a graduate of the... First president, the second. I think I was referring to Ray Davis. He was from you, okay. But we're very proud of you being a product of our school. So, ladies and gentlemen, look at your president. He is the example for you. He's been here with us as a student, went overseas, and is now back with us. Perfect example. That's what I'm hoping for most of you. All right. At this time, I'm going to ask our sponsors, before we go off on break, a few of our sponsors to come and talk to us. And the first sponsor who I'll invite to the podium, thank you, is Mr. Rick Case from the JPS. And you heard President Brown refer to JPS. Now, example of JPS right here is a product of our program as well. And I could call him Mr. JPS. He would get up anyway. All right? Thank you, Mr. Case.
Thank you. Good morning. Thank you, Dr. Brown. All protocols observed. I am officially thrown under the bus. But a lot of what he said is actually work in progress for us. So we have a shared vision where that is concerned. JPS is pleased to sponsor the UTEX School of Engineering and Computing Major Project Conference for 2024. We are also pleased with the theme, Engineering for the Future, Research and Development for the Continued Growth of Jamaica. The future excites us, particularly now that JPS is celebrating 101 years of providing energy services to Jamaica, and also recognizing the responsibility we have to engineer the energy system of the future. And note, I did not say grid of the future, because conceptually you might not necessarily have a grid in the future, but energy systems will be there. But just suffice to say, the grid of the future continues to face what we call the 3D challenges. And these are decarbonization, decentralization, and of course, digitization. And in solving these challenges, that is the responsibility of engineers. And also we have to solve these challenges bearing in mind corporate social responsibility and energy equity. Too far we have seen now where energy is breaking up into haves and have-not components, particularly in the renewable energy space. And usually in the middle, there's a disenfranchised community that is underserved. So we have to be very careful in the future energy system that we actually create. Of course, all of this requires research and development. Dr. Hales went deeply into that, and I'm happy that that is a key component of the theme today. But just bearing in mind that, and you might not need a reminder of this, but engineering sits between societal needs and science. So engineering is that solution bridge between societal needs and science, and Dr. Hales did a wonderful job in kind of bringing all of that together. So society drives the demand for what engineering has to take from science to create those conveniences, those social goods, those programs, everything. So we are keen to see the work of the final year students. Some of the topics I've looked at so far, I've seen where we're responding to climate change, air quality. I'm seeing projects where they're incorporating seaweed to make concrete blocks. I'm seeing projects where they're taking sargassum to make plastics. I'm seeing projects also where we're solving congestion problems on the road, including bypass to Spanish Town. I'm seeing the renovation of the Coronation Market. Those are things that we need. And I'm seeing this as a bedrock. If the university is doing this, then this definitely is a source of revenue, I think, for the university. And this is a commendable step. I personally have vested interest in the university's program because I'm looking for talent, and JPS is looking for talent. And so far, several of your graduates have, through this major project presentation, have ended up in our employment, just from the interaction that we have during the presentation. So please do not take it for granted. You actually are, you may be performing an interview, right? So for us, we have a vested interest in there, and I can call more than 10 engineers who are working with us now, who have selected from major project presentations. So I'm happy with some of the work that I'm seeing so far, and I'd like to thank the organizing committee for this invitation to participate in what seems to be a high-quality event. Dr. Brown kind of spoke about it in our days. We never had anything as fancy as this, so I'm happy to see where we're progressing. And JPS is committed to this program. Right? Some of the things Dr. Brown spoke about, he's looking forward to the relaunch of the Power Lab. I certainly am looking forward to it too, as well. And we have some work that has already started there. We have our engineering internship program, sent the information to Dr. Isaacs and also to Dr. Chambers. So final year students, we basically take the best of the best, and you're on a 1-year engineering rotation program where you go through all the technical areas at JPS, and we typically hire you after the year. So you basically become a robust engineer, and that program has served us well. Several graduates from the university are in our employment now from this program. So I invite you to take up that opportunity, and we look forward to talking to you. So thanks again, and thanks for the opportunity for inviting JPS here, and congratulations on your conference.
Thank you very much, Mr. Case. You've our long-term supporter. We're really appreciative of the Jamaica Public Service. Our second sponsor that we'll invite to the podium is from Huawei Technologies Jamaica Limited, and that's Mr. Errol Smith. Can you just welcome Mr. Smith?
Morning, ladies and gentlemen. Morning, Professor Thorpe, O'Neill, Joseph. Morning, Dr. Chambers. So we're very happy to be here. Well, let me introduce myself. Sorry. So I'm Errol Smith. I'm the head of engineering at Huawei Technologies Jamaica, and one of the project directors in our office. So we're happy to be sponsors here at this event. We were here last year, and of course I'm very happy Mr. Von Alexander reached out to us again to help with this event. It's getting bigger, it's getting better, it's more organized, and for that I think is a good is good for the university. So just a bit about Huawei. So Huawei Technologies actually is the #1 telecoms provider in the world. We achieved this feat in 2012, and we've been able to be #1 since then. The company was started in 1987, so it's somewhat a young company. Yes, it is. It's 37 years. They may think it's old because they're very young. But to achieve this over 37 years is really good. It's a private company, so truly the owners are the employees. So most of the employees are given stocks in the company and so forth. So it's also a good way to ensure that we work very hard. For the Jamaica arm in Huawei Technology, we're located at 97 Hope Road. So we have hired, and we're even now, we just completed interview for our internship program. I believe we selected 5 UTech engineers. And of course, as our JPS colleague mentioned, generally after this internship program, which lasts about 4 to 5 months, generally we hire the person, so you get actually a permanent job in the company. So definitely, as much as I mentioned that the interview is finished, we will still be paying keen attention to the presentations for the final project. So a bit about what we have to offer and what we've done. We work closely with Digicel. We work closely with Flow in providing telecommunication services here in Jamaica. We offer Seeds for the Future program. It ended last year, October. We'll have a new one this year where we take the brightest students Last year we held the event in Costa Rica. This year it will be held in Peru or Chile. We're not clear as yet. And from this is actually a competition. So from the multiple markets in the region, Huawei is in Trinidad, Dominica Republic, Panama, there's a competition, and we will choose some of the best local seeds for the future, and they will have a month in China to visit the Huawei University and go on a pretty nice tour. China is very nice. You guys are technologically inclined, and that's the mecca of technology. So, as I say, thank you very much for inviting us, and I viewed some of the projects. They're exceptional. I like the ideas and where we're going, and of course, all the best. Thank you.
Thank you very much, Mr. Smith. And students, please bear in mind that our sponsors, they have their booths outside. They're all set up outside, so please feel free to go and visit and talk to them if you want to hear some more. All right? We're at the point where we're going to break now. I have it here for 15 minutes, but just to, keep time, we're going to break for 10 minutes. But before we go off on break, I'm going to ask Mrs. Jameson to come and make a presentation to our sponsors. So I'll invite Mr. Case first, and then Mr. Smith. And that's a certificate of appreciation. Thank you very much to JPS. Mr. Smith. And again, thank you very much, Huawei. All right, so our first session of the day is over, so I'll ask you, you can go outside, stretch your legs, refresh yourselves, and be back here in 10 minutes. So we'll resume at 11:36. Okay, welcome back. I hope you're all refreshed now, and we are getting set to resume. We have presentations going right up until our next break, and we will begin with the presentation from the GIE. I know on your program it says Engineer Norman Tai, but unfortunately he is not able to be here this morning. However, he is being represented by Engineer Marvin Reed, and he will be speaking on From Classroom to Career, Navigating Your Engineering Journey. Engineer Reed, where is he? Okay, yes, he's coming down.
Everyone comes in, or
No,
proceed?
They'll come in.
All right, so good morning, everyone. So I'll like to extend special greetings to our moderator, Dr. Therese Chamber, the head of School of Engineering, Engineer O'Neill Josephs, the Dean of the Faculty of Engineering and Computing, Professor Sean Thorpe, and the chairman for the Major Projects Conference, Mr. Vaughn Alexander. So today I would like to start my presentation acknowledging God in our presence. I would like to make reference to Philippians 4 verse 13. We can do all things through Christ who strengthens us. All right, so this session, viewing the theme, Engineering for the Future, Research and Development for the Continued Growth of Jamaica. So, fellow engineer Norman Tai called me this morning asking if I could represent him today, speaking about From Classroom to Career, Navigating Your Engineering Journey. So this is the impromptu speech, basically presenting what are presenting in a chronological order from the elementary level all the way up to the tertiary level. So just to introduce myself, I am Michael Reed, a civil engineer at the National Works Agency. I'm also a graduate member at the Jamaica Institution of Engineers. My specific interests is in hydraulics engineering and traffic engineering. So going in a chronological order, there are 6 main concepts in an engineer's life, right? So we have 6 main concepts right throughout our lives as engineers. So firstly, we have basic or elementary school. This is where we deal with the rudimentary concepts of life, where we firstly understand about the physical world, and we also understand basically normal movements. So at this stage is where we learn about the Newton's third law. Every action leads to an equal reaction, right? Students? Right, good. All right, so at least I haven't forgot those fundamental principles. So at this point, you started to walk, right? So unbeknown to you, you've achieved or have realized that first concept as it relates to Newton's third law. The secondary level now is at the primary level. This is where you become more accustomed to engineering, in the sense of things going on around you. You start seeing a specific car that you like. For the men here, you start to see, for example, a 3-cylinder vehicle. You start to acknowledge, all right, it makes a lot of noise. You like this stuff. And that has to do with the mechanical aspect of stuff, mechanical engineering. For the build systems now, which would be civil, that's where you see like a traffic signal on a daily basis. You're starting to see, all right, there's a lot of traffic congestion on the roadways. So you've become acclimatized to these conditions, and you realize that, all right, you're within the field, and you have to get yourself acclimatized to those things in the built environment. At the secondary level, this is where you've gained or garnered enough knowledge to know, all right, so these are the different aspects of careers and what you want to do specific to engineering. Most students, they have a knack for the sciences at first. Some go towards the arts, but from primary level into the first 3 years of first, second, and third form, you're doing all the sciences, and then when you move on to grade 10, you're looking directly at the physics, the pure maths, or the odd maths to further your studies in engineering. At the tertiary level now, that's where you'd have needed you have gotten your prerequisites from your high school. So these include your CXCs and the CAPE specific to your CAPE math, your CSEC math, inclusive of odd math for who did it, because I didn't do it, so I struggled at the CAPE level, so I can actually see where a lot of students had issues with math 1, math 2, and math 3 going into their tertiary studies. So just to segue a bit, I studied at the University of the West Indies, Mona, graduated in July 2021. I'm originally from Montego Bay. I went to the best all-boys school in Jamaica, Cornwall College. One college. All right, so moving into work-life balance. As we say, from classroom to career, navigating your engineering journey. So I just wanted to go in a chronological order just to emphasize the elementary level, up to the primary level, up to the secondary level. Okay, up to the secondary level, and then into your tertiary education, and then into your working life. So upon graduating from whichever university, whether it be CMU, UTech, UEMONA, or even abroad, because a lot of persons did their first degree abroad and then came back to Jamaica to work. So upon graduating, the first year, most times it's internship, and most times some persons are lucky enough to delve deeply into a full-time job straight out of university. And most of these full-time jobs require you to have at least 3 years experience. So I was one of the lucky few that had only 3 months experience and got a job with 3 years. That requires 3 years. So I must say to you, when you're job hunting, you want to look on whichever institution, whether it be private or public sector, and the emphasis to gain knowledge, gain experience, so you can apply to yourself and to apply in your working life. Like for me, for example, when I was in second year, I started to tutor structural mechanics at the University of the West Indies from second year, and then third year continued, and then final year at UNO, I tutored structural engineering. So my emphasis throughout my undergrad, my special investigative project, and my civil design project was based on structural engineering, because I wanted to become a structural engineer. But fast forward to I did my internship first at the Jamaica Premix. So I did 3 months there, and then I went to the National Work Agency where, we deal with, the National Works Agency deals with hydraulics and traffic. Those are the 2 main purview of the agency, right? So I delved deeply into traffic, far from what I loved at university, at the tertiary level, but I've grown to become a lover of traffic engineering as it relates to studying the impact that corridors will have on developments right across Jamaica, feasibility studies, black spot surveys, traffic management plans and projects. So these are the things that I've learned to appreciate, and I'm 100% sure now that I've turned my interest away from structures and is directly focused on traffic and hydraulics. So the working life balance that you have to find, you have to ensure that where you are, you're learning. You want to pick the brains of your superior or your supervisors at all times, no matter the question, you need to know the jargons, understand the concepts, understand the rudimentary concepts from the physics and the pure math that you did at university and at the secondary level. And then when you go out in the working world now, you realize that there is a lot of jargons that you'd use at university that will be used at your workplace. So some of these jargons, for example, antecedent moisture conditions of a specific soil type, a long concept, but it can be broken down as it relates to the amount of moisture that the soil will hold and before it allows for surface runoff. So those are some of the concepts that you have to understand and the jargons you have to know in the work life or when you're working. However, you have to always strike a balance. However, public sector is different from the private sector. Sometimes in the private sector, it's a culture or it's a company culture to know that, all right, you reach work at 7 a.m., however, can't leave until 7 p.m., even though on your contract or on your letter, it says from 9 to 5. So these are some of the things that you just understand the culture, and you just need to understand it's learning, right? And one of the main fundamental things I like to tell persons is one of the main things for most private consultants, their main aim is to bid for projects, right? Submit their tenders for specific projects. And most of the engineers that will be under that specific tender are experienced engineers, right? So you're there just to learn, to be a part of, and to gain the requisite experience so that you and yourself now can be a part of those teams going forward. So moving on to retirement and consultancy. So as engineers, there is no such thing as retirement. It's the honest truth. Reach 65, go into consultancy, right? So there is no point in your life where you'll say, all right, I'm gonna hang up my boots, hang up my pen and my pencil and my design softwares. You can always use it right throughout your entire life, right? Because the wealth of knowledge that is within this room right now, Mr. Alwyn Hales is here. He can tell you that you won't ever retire. You'll always give back. There's always younger minds there for you to bestow information upon, right? So I'm just saying this to say, in engineering, it's a lifelong learning. So for example, during the 90s or 80s when you had to do hand drawings, now you have design softwares that are CAD embedded, AutoCAD, Revit, Civil 3D, SSA. So all these softwares are here now, which weren't there in the 80s. That doesn't mean a person from the 80s can't appreciate or learn to use these softwares in nowadays, are more advanced softwares, right? So it's a lifelong learning, and you always have to keep abreast with information. One thing I recommend as well is to emphasize during your working life, to the continued renewed of information that's out there. Just keep on reading, keep on learning. If it's some short courses you have to do, getting a master's, definitely. Just continue reading, researching, looking at the new softwares that are out there, because these softwares, the main point is to have information being processed to a simple level, right? Right, so in concluding, I'd like to touch on ethics. So ethics is a characteristic that should be innate in every engineer, right? So there's a lot of things going on now. However, we have to be steadfast in our approach to our working life and in our career. Same like how if I'm designing a building now and looking at the live loads for a typical structure like this, firstly, I won't be saying that nothing at all will be on the roof. I'll be looking on whether the MEP systems that will be up there, and I'll be looking for my design codes to make those design assumptions, right? And also looking at the post-construction. And in the event there will be a next facility being placed up there, then you'd have to design where you have your moment bars and everything designed to those specific standards. So I just want to acknowledge that your ethics and your design codes, treat it like your design codes. When your life you have to operate in a certain condition. When you're designing, you're operating in a certain condition. You're not going to design any little inferior building for a big contractor, or a big consultant, or a big client, because that affects your integrity. And so you want to treat it like you're designing, right? Likewise, in road construction, you have an AASHTO code. For me specifically, my quote-unquote technical Bibles are the MUTCD, which is a manual on traffic control devices, and the highway capacity manual. And the one that is so, a lot of persons probably know it, is a TripGen manual, right? So in concluding, I'd just like to emphasize the point of when you reach the point of, a well-seasoned and experienced engineers, always remember to give back to your alma mater at all levels throughout your life, your primary, your secondary, and your elementary. If even is going back to tell the students, say, hey, I'm an engineer, and the moment they see you, they say, all right, they'll look upon you with a certain level of respect, and they would like to be just like you. So we have to get in the schools at the primary, secondary, and tertiary level, in educating the young men and the young women that, hey, STEM is the way to go. Whatever the career, whether it's engineering, medicine, any other field throughout STEM, that is the way to go for us to have a successful and move past the stage of a developing country, but into a more modern and technological advanced country, because the resources are here. Resources are here, that's a fact. So we also have to use these resources wisely and educate the masses that, hey, we have to move into a more technological realm. And yes, gatekeeping. So lastly, is about gatekeeping. So you don't want to keep information from to yourself, especially engineering world. So as I made reference earlier, as an engineer gets older, he's able to pass on knowledge to younger engineers. So I've been blessed with my supervisor at the National Works Agency. Any question that I have, I can knock on their door and ask anything at all. We can have a lively discussion about anything as it relates to working world or just navigating the life of a young engineer. So I'd like to leave a statement or a token with everyone with a Bible verse closing out. John 3, verse 16. For God so loved the world that he gave his only begotten Son. So whosoever believeth in him shall not perish, but have everlasting life. Thank you very much.
Thank you very much, Engineer Reed. And notice how I addressed him, Engineer Reed, because as soon as you become a professional engineer, you are addressed as such. Oh, no, we're going to go into another presentation now, and I think, Engineer Reed, there is a question here for you. Prof. Wilson has a quick question.
One question. Why is the limit on the highway north-south 80 kilometers? All right. This time, can you drop up what is the question?
All right, can you repeat the question? Well, I'll give it. Sorry.
North-south highway. Why is the speed limit 80 kilometers per hour throughout?
All right, so to answer that question, so I've been privy to a lot of documents. I can't say over or in this space. However, the reason why it's 80 kilometers per hour, based on the design of the horizontal curves and the vertical curves, you have to maintain a certain design speed. This highway was designed in and around, I think around 95. However, you have to allow for a threshold to accommodate for a factor of safety. So you can't allow everyone to go, or you can't encourage motorists to travel at the design speed, but you have a posted speed limit. So reference is made to the horizontal curves on the highway and the vehicular and the vertical curves. And these are basically design standards that relate to the super elevation of said roadways. Second to that as well, you probably realize that there's a lot of stretches along that corridor that would allow you to go above or even to 110 kilometers per hour. However, no one. Yeah, even 200. You have vehicles going that. So I understand, but at the end of the day, that's why we have the law enforcement to ensure that these speed limits are maintained. Well, the thing is, all right, so it's for me personally, in engineering, as an engineer, you can't design to mitigate what people will do. What you have to do is design and based on your standards, your codes. However, we have a culture issue in Jamaica. Unless there is something looking over us and saying, hey, don't do this, then you're gonna do it. But as I say, based on the design though, it is based on the horizontal and the vertical curves and the super elevation on the roadways, right? Repeat?
Why not a limit? Say between 80 to 100, 60 to 90. Why just that?
Posted limit? All right, so as I said before, I wouldn't be able to answer that question deeply because, based on that design, when Czech was doing it, it was a whole lot of things. But I can make reference to the design standard as to why that speed limit would be posted. And as I said, as I made mention, if you're going down the orange section there, right, as I reach Iwaton here, there's a long stretch that can go up to even 110 or even 180. However, to maintain a certain standard and for persons to travel at a certain speed, you have to maintain the posted speed limit right throughout. Right, and an issue that we're seeing now, which was mentioned, it was one of the points at last year's GIE conference that was presented by Engineer Bloomfield from SJE, was at the roundabout at Mommy Bay. There has been a lot of accidents there, right? So one of the cases there, you're going on an incline and you generate speed, especially in those trucks, they're carrying tens of tons in the back. So it's kind of hard for you to say, all right, let's design based on that. What we can do, or what we've been doing at the National Works Agency is looking at traffic studies of how we can mitigate and even change the alignment of that section, where they're going to be changing it to a 4 intersection with a slip lane at the end to accommodate failing or a vehicle that has, or a truck that has mechanical issues. So those are things that we're looking at. But for the posted speed limit is solely the horizontal, vertical curves and also the super elevation of this corridor. As you can see, there's a lot of Lamborghinis and everything here, so,
Okay, Engineering, before you go, Mrs. Booth Thompson has a presentation for you. While she's doing that, Prof. Wilson, you didn't tell me you had your Mercedes, no? It's not the Autobahn. You notice a theme here, ladies and gentlemen? Ethics, right? Ethics. I hope you picked that up. All right, so our next presentation, set up 2 presentations. They're really in-house presentations. No. The first one of which is from the UTech Formula Student Club. Did you know that we have that one? How many of you knew? Did any of you participate in the club? Let me see the hands. All right, I see only one hand. Anyway, I'll ask Mr. O'Neill Mason to come and do the presentation. Put your hands together.
Thank you very much, Master of Ceremonies, Head of School, Mr. Joseph, Guest Speaker, Dr. Hales, Program Director, Dr. Graham, all our guests and our students in the audience, and for those online, thank you for joining us today at this year's engineering conference. Whilst I wait on the video to be connected, I have a short video to show you whilst I present. So at this conference, I thought not to do so much of a lecture type presentation. I wanted to share with the students, especially the third year students. I noticed many of them are not here today, but I'll still go ahead with the presentation. Hopefully it can inspire those of you who got this far in your career and now on the verge of heading into the industry to see some of what you have to do. So I thought, let's share my story. So as you can see, I actually got on my kit from my previous racing experience with Formula Student, because in this presentation, what I adapt the words of the great Nelson Mandela. Some things seems impossible until it's done. And that's what I want to inspire you today. Many times as students, you get this task. You think it's impossible. It seems like a mountain. But if you have seen someone done it before, you are most times inspired and can do it. Believe in yourself, you can do it as well. So as we get the presentation up, I will share my story with you, my journey. Share what some people think about Formula Student. It's a new program here at the University of Technology, and I can tell you it's the first in the Caribbean. And the University of Technology Jamaica is proud to be the institution to introduce that to this region. So whilst we get over these little technical difficulties, I'm sure within a minute our technical team will get it going. Right, so there are many views on Formula Student, what it's all about. I have a particular take on what it is. And my take is that it's a unique opportunity. However, let's just bring you back how Formula Student actually got here in the first place. And this is a story to do with the head of school, Mr. Joseph, and a number of other staff here at the University of Technology, had a visit to the United Kingdom on a program to do with a partnership with some engineering between here and the University of Birmingham. Whilst they were there, I think they got introduced to a Formula Student program at the University of Birmingham, and needless to say, they were intrigued and excited about it. So they decided to take it back here to the University of Technology, Jamaica. Now, during that time, they never know me. They knew nothing of me. I perhaps was still in the UK and was on my way here. Now, they introduced, I was told the president introduced the program, I think sometime last year, am I correct? And they were still working on it. They were seeking partnership or help from the University of Birmingham, which introduced them to the program to help develop the program. However, I came into the picture, and there you have it. The rest is history. I'm now telling you about it. Now, so what is Formula Student? According to the IMechE, which is the institution which supports it in Europe, it is the largest engineering program, student program in the world. There are many other views about it, but as I said earlier, it is a unique opportunity. Now, SAE, which is the Society of Automotive Engineers in America, Houston, Texas, was the one who actually inaugurated Formula Student in around 1981. They started their Formula program. It was then brought to the UK, and funny enough, the University of Birmingham was one of the first universities to actually enter that competition in around 1997. Around 2007, the program was taken to, as it grows, with a number of institutions adapting the program. It was brought to the Formula One racing circuit in Silverstone, in England. Right, so Okay. Sorry about that. We seem to have a bit of glitches with our system, but what I'm doing there is to borrow a video from AMZ to show you how they actually design and assemble a Formula Student car. That is an electric car, by the way. I need to get over this.
Wait for the day that all your suffering is gone. To choose to live a happy life.
Work on those. I will ask the program director for the Masters in Engineering, the MSc in Engineering, to come and do his presentation. I know on your program it says Dr. Paul Campbell, but the program director is actually Dr. Milton Richardson, and hopefully we won't have any technical issues here. Right, Dr. Richardson?
Thank you very much, Dr. Chambers. I must first a pleasant good afternoon to our distinguished guests, faculty members, our students, esteemed students, and our future engineers. My presentation here, well, before I go into my presentation, how many of you here, I want to see by way of raise of hand, are aware that in our school we have a graduate program? Okay, about 50%, all right. I know at this point most of you are contemplating what is the next step, right, as you complete your undergraduate journey here at the university. What is the next step, right? So what I'm going to be taking you through here is some offering that we have in our master's program. The overview of my presentation, I'll first look at the program structure, then I look at the mode of delivery. All right, so the MSc in engineering, it's very much industry driven. So our curriculum is one that is dynamic, right? So it is based on what is happening in industry. We try to align what we deliver in that manner. Right, there are 7 specializations that are on offer to date. We have our mission statement is to create a rounded yet deep graduate able to operate on several fronts. And these fronts are 1, leader and communicator, analyst, specialist, and the researcher, right? So I'll be showing you how our curriculum is hinged on these 4 pillars. Now, the entry requirement for our program, you need to first have your bachelor's degree, BSc, or it could be a BEng degree with a GPA of at least 2.7. And there's a preferred 2 years work experience. I know you don't have the work experience just now, but please apply. In terms of the whole structure and the design, we offer our programs over a 2-year period, and it is on a part-time basis, and it's 38 credits, and the modules are pretty much taught modules. It's over that 2-year duration that I mentioned, as well as there is a research component to this, right? I will talk about this towards the end of the presentation. In terms of how the courses are delivered, it's delivered over a 5-week period. That's a cycle. So every 5 weeks, there's a new module that you'll be doing, right? And there are 2 evenings, right, in that 5 weeks that you will attend to those modules. And what is good about these courses is that they are done remotely presently, and for the academic year 24-25 and onward, these modules will be fully online. So you can do that. You don't have to come here to do them, and I will give you some more details about that in a little while as it relates to our flagship program, the MSc in engineering with specialization in management. So what are the career opportunities? Right, we have a few here. I've listed them here. There's a design engineer, right, construction project manager, senior mechanical engineer, senior electrical engineer, and so on. I've just listed a few here. This list is not exhaustive by no means, but just to show you the potential that exists as it relates to your career growth. Now, in terms of the module sequencing guide, we have, as you can see here, the faculty core, the engineering core, and there's the specialization core, and then there's the specialization electives that you'll do, and then you will have the research project at the end to do. And in this table, I'm showing you the number of courses that you'll need to do and the credit ratings here. Right, so remember initially I told you that this program is built on 4 pillars, right? So I've shown you here how they are linked, right? So the core modules, right, that is where the leadership and the communicator aspect is supposed to come out, right? So you will do 3 of those modules with a total of 8 credits. So 2 of those modules will be 3 credits and 1 2-credit module. So that's how we have 8 there. For the engineering core, you do 3 modules, and that's 3 3-credit modules, right? So that is a total of 9 credits. And for the specialization core, you'll do 3 modules, right? Each being 3 credits, so a total of 9 credits. And for the elective, you will select 2 electives, and each elective has a value of 3 credits. So that gives you a total of 8. And your research project that you'll do last, that has a value, credit value of 6 credits. And this research project is done over a 1-year period, right? I'll talk about that in a little bit more detail later on. Right, so let me start with the core electives. What are the core electives that you'll be looking at? All right, so we have 2 flagship programs presently. The first one is the engineering management, right, that one. And then we have the renewable and distributed energy engineering, right? So these 2 have, in recent times, have the most subscriptions. We also have other specializations that we can offer, right? And we offer them based on the subscription, right? So the others are the sustainable infrastructure and development engineering. There's the supply chain and logistics engineering. There's environmental and natural resources engineering. There's telecommunications engineering. There's chemical and thermal fluid process engineering that we offer, right? So how these are built out. We have the core, right? So these are the core modules, right? We typically would start about September and end in December with your core modules. You start with the engineering seminar, and there's a project management, and there's the research and equipment design, right? So 2 of the modules are 3 credit and 1 2 credit. So that's how you get the 8 credits I mentioned earlier on in the. And then in January to May, that's in the semester 2, right? You will do the engineering core modules, right? And these are 3 modules that you will do, right? So these are the 3 that I've listed here in the table: the advanced engineering analysis, the operation research management, engineering economics, and the research project, right? So these are the 3 modules. Now, for the specialization, so all of you will do these courses, right? The faculty core and the engineering core, right? So if you're inclined for leadership roles or project management roles or professionals seeking just a blend of the technical expertise with the management skills, then this specialization here is for you, right? The engineering management specialization. So there is the core that you'll do, right? Select from these. Well, these you must do, right? The systems modeling and simulation, the management of technology, the risk analyst, and reliability engineering. And then you will select 2 from the electives here, right? So 2 of them. Now, if you are inclined or so passionate about renewable energy sources, sustainable power systems, and those looking to work in green energy sectors, in particular as our energy space now is looking towards the renewable energy. So the renewable and distribution energy engineering specialization is one that you could take up. And again, the structure, when you look at it, we have the 3 core modules that you will do, right? Sorry about that. Right, the renewable energy system, the electrical integration of renewable energy, and the energy management. And then you'll select from the list of electives 2, right, for your specialization. And we also have this one, environmental and natural resource engineering specialization. And this one is in particular if you're so inclined or interested in environmental protection, sustainable management of natural resources, or just I'm interested in addressing ecological challenges through engineering, then this one is for you. And again, you do the core in the specialization, 3 modules here. Environmental impact assessment, there's the environmental engineering and the renewable energy systems, and then you select 2 from the electives. And we have this specialization, sustainable infrastructure and development engineering specialization. And this one is if you're focused on designing sustainable infrastructure, right, or urban planning, in particular those who are dedicated to promoting sustainable development in construction and civil projects, then this one is for you, right? And here you do these 3 core modules, right? The environmental impact assessment, right? Management, infrastructure, mega projects, and the risk analysis and reliability engineering. And you'll select 2 modules from the electives. We have this one too, this, supply chain and logistics engineering specialization. Right, if you are so inclined, where are interested in optimizing supply chain operations, right, or logistics management, right, or just improving the efficiency in manufacturing and distribution networks, then this one is suitable for you, right? And when we look at the offerings, right, we have logistics and supply chain management, logistics facilities and process, and we have systems modeling and simulation, and you will select 2 from the electives that are shown here. Our next specialization, telecommunications engineering, and this specialization is particular for those who are fascinated by communication technologies, right, network systems, and aspiring to work in telecommunication industry, right, and of course this includes the mobile and internet service providers. So the core modules, right, these are the 3 core modules that you will undertake, right? So there's advanced electromagnetic theory, advanced digital communications, antenna design, and you select 2 electives from the offerings, right? And our last specialization here, right, it's the chemical and thermal fluid processing engineering specialization, and this is for the engineers that are keen interest in chemical processes, right, and fluid dynamics, heat transfer, based on the courses that are here. Those aiming to work in industries like petrochemical and the pharmaceuticals and energy, right? This one is for you, right? And again here, you do 3 core modules in your specialization. That's advanced transport phenomena, and you'll do finite element methods in mechanical engineering, and you do thermodynamics and combustion. And then you select 2 of these electives that are shown here in the offering. And last, there's the master's project that you'll do. Like I've said, it's a year-long research project. And these research projects normally can pull from 3 areas, right? Could be from the industry, right, or the private sector, where you look at challenges, and it could pull from government, right, based on strategic initiative, and it could also come from the school itself, right? So it's normally based on real-world problems. All right, so now you're probably wondering, so what will it cost to do this kind of a program? The cost is approximately $1.3 million. Right. Yes, there's a payment plan that is available, right? Yes. Right. 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 This is in total, right? So for the 2 years, right? That's what you pay. Not each year you pay $1.3 million, right? So this $1.3 million represents the total cost to do the program. All right, so of course it's subject to change based on inflation, right? And of course, you should be prepared to pay the ancillary fees as well. All right, so I hope you're inspired somewhat to apply to our graduate programs. Right, so if you have any questions as it relates to the program, I'll take them now. why is it a Master of Science as opposed to a Master's of Engineering? Well, there's really not much difference between doing a Master of Science and a Master of Engineering, right?
There's a slight distinction between BEng and a BSc. You're doing a BEng because of the extent of your laboratory experiences. It's laboratory intense, right? And that makes you different from somebody who does a BSc in engineering. We're not saying that a BSc in engineering doesn't have sufficient labs, but a BEng in engineering is lab intense. At the master's level, it's not going to be. At the master's level, the focus is. Yeah, right, sorry. At the master's level, the focus, you will do simulations and computer-based labs, but it won't be as hands-on because there's really no need, to be honest. You won't be in a physical lab conducting that, the kind of experiment that you become accustomed to at the undergraduate level. So it can be designated as an MSc. You understand? All right.
All right, thank you very much for that input. And are there any other questions? Yes.
Can you speak more regards to the payment plan? What are the different payment plans?
All right, like I've said, the payment plan, this can be done per year, per semester, or per month. Typically, the payment is divided equally. Any other questions? Any other questions? If there are any other questions, you may contact, please feel free to make contact to the Graduate Studies Office. All right, this is my email. Right, so mrichardson@utech.edu.jm, or you can reach out to our admin support as well, right, who is Mrs. Teresa Ramsey. Right, her email is tramsey@utech.edu.jm, and you may reach her at this number, right, the extension, right, 2158 or 2046. All right, so this concludes my presentation, and I'm looking forward to receiving a number of applications from you. All right, thank you very much.
Thank you very much, Dr. Richardson. So, yes, so you need to go and work some money and come back, right? And you know, the benefit of, the beauty about graduate studies is that your employers might actually pay for you to come and do it. So don't forget us. And also, we are quite competitive in terms of the fees when you look at the fees that you would be paying overseas. So you may be better served staying. All right, so Mr. Mason is going to do his presentation now. I think all the kinks and glitches have been worked out, hopefully.
I think we shall now have another go at it. Hopefully this time it runs smoothly. I think they're trying to sabotage this Formula One thing, this Formula Student program. It's not going to happen. Not under my watch. It's not going to happen. They can try their best. It's not going to happen. Oh, by the way, if there's any consolation in it, I've paid a lot more than it's been offered for a master's program here, overseas. So consider it cheap. It's put it presentation. Okay, so the first video which I was showing, I want to show on here, is a AMZ presentation of their representation of a Formula Student car, how they put it together, the composition, and this is an electric vehicle. Now, I may inform you that between the head of school and the president want us to look into developing an electric vehicle as opposed to an internal combustion engine vehicle to begin with. So that's just to say I'm giving the electrical department an heads up that I may be approaching their office quite soon and have a conversation about putting that together. Now, real engineering, that's where we want to go. We're a university. This institution, a STEM university, that's what we want to promote, real engineering. So as you can see there, it looked quite fancy on this screen, how we put engineering products together, assemble them, and normally, as an engineering, when you're working for an engineering company, that's how they would present their new product to potential customers. So we need to get used to that mindset. That's how we go about doing things. Okay, so this is just a quick render to show you how it all comes together. And then I'm going to jump into the presentation. This is done by an institution in Europe. I think it's in Switzerland, that's just what they're focused on, developing Formula Student race car and race them annually. Okay, so the intention of my presentation today anyway is to, as I said earlier, is to inspire you guys, engineers, prospect engineers. As you know, enter the world of work. You'll be now seeing engineering in its real form. Now, I'm here to talk about UTEC Racing. It's going nowhere, it's now here, and it's going to be here to stay. Now, that's the proposed name, UTEC Racing. I think it's open to dialogue. We might change it in the future, but that's down to the participants, the team members who will take the program or take the club forward. We may look into change it, but for now, that's what we're working with. Also, the logo. I think they chose this car. It has nothing to do with me, but if you have any problem with the shape of that car, please have a word with the president. But remember, book an appointment before you go and see him pertaining to the car. Anyway, sponsored by the University of Technology. They're quite interested in this presentation. And as I mentioned earlier, the University of Birmingham is a partner or a proposed partner in this program. I am O'Neill Mason, and I'll be talking to you for the next couple of minutes about this program. Right, so what is UTEC Racing? Well, that's the official name of the University of Technology, Jamaica, Formula student team. And what is Formula Student? Now, according to the IMechE, which is the Institution of Mechanical Engineering, it is the largest student motorsports event in the world. Now, the likes of Willem Todd would say that Formula Student is an educational engineering challenge that allows students to design, build, test, and evaluate a race car against other students from universities around the world. Now, this guy has over 30 years in experience in Formula One aerodynamics, and he's a professor at the University of Bolton. He still teaches, and he teaches aerodynamics. He works with a number of reputable Formula One companies as well. Another guy who seemed to have something interesting to say about Formula Student is a British Formula One and Motorsports Managing Director, Mr. Ross Brown, and he thinks that Formula Student is a fantastic initiative which gives its entrants the freedom of design and test their ingenuity, whilst also providing practical experience of working in teams to specific deadlines, budgets, and regulation. But Formula Student really is the competition really offers the team. This is just the official definition, what the organization offers teams the opportunity to undertake real-life challenges and logistics and develop the skills they will need when they go out to the work in industry. The aim of Formula Student is to challenge university students from around the world to design and build a single-seat racing car, which is then put to the test at a racetrack. The objective, students will work together on the car, develop their creativity, technical ability, teamwork, and communication skills, as well as learning how to develop projects to budget and deadline. Right. Now, as I mentioned earlier, it is managed in Europe by the IMechE. It is managed in North America by SAE, which is the Society of Automotive Engineers. So, graduates from these programs normally end up, for the most part, in Formula One as engineers, right? So it's a way of creating their own pool of engineers for the future. So the Formula One industry supports this program. As I said, we now brought it to Jamaica, and I mentioned earlier, that's my take on it, it's a unique opportunity. So, I mentioned that many times since I started. And as I said, I adopted the words of the great Nelson Mandela. It always seems impossible. I know many of you may sit here thinking, as for those students who have done it this semester or last academic year, and they saw the challenge they had to go through. It's a new dawn. It's a new era. And it's not easy, but any real engineer will tell you nothing in engineering is that easy. You will kill people. If it was that easy, everybody will do it. It's not that easy. And I will also go as far as saying engineering is probably the backbone of every society. Everything you can think of, perhaps, maybe not the plants, but if you think about it deep enough, maybe. But engineering has something to do with it at some level. Let's look around the room and tell me something which is there which is not developed by an engineer. Now, I put on this, my old team gear. It was really tucked away. I've not looked at them for a very, very long time. But I thought, how best could I inspire you today? By showing you that I've actually done it. So I wanted to tell you a story, take you along my journey. I've heard Engineer Norman spoke earlier that he went to the best boys' school in Jamaica. Well, I didn't go to an all-boys school, but I beg to differ. I went to Dintil Technical High, right? So I'm going to take you back on my journey, how I got to where I'm at today. And I studied automotive engineering. That was my option. It's a long story to go back, but even before that, my dad had a garage anyway, so I was always around cars from a young age. After I did very well at high school, so I enrolled at the Jamaica Automotive Engineering, Jamaica Automotive School, and for 3 years, and I'd done that. When I finished, I said to myself, I want to be a professional mechanic. So I enrolled on a course at the University of Birmingham, funny enough, to start my degree. No, after Jagas, I worked for BMW, Sterling Motors Limited, as a BMW technician. And I was a member of the team which actually assembled the first Z3 that came to Jamaica. It's a Z3 Coupe. Does any of you remember that car, by the way? Yes. Oh, could you? You weren't here then. So 20 years ago. Actually, I came to the University of Technology with it, and there was a crowd around that car. Anywhere I drove that car on the street, JUTC buses, they would stop just to let me pass to look at the car. But, unfortunately, that car, may God rest its soul, is no longer here with us. An excited member of our staff thought that he could go and test this car at maximum speed because he heard that BMW has one of the best anti-roll technology, active dynamic system. But he didn't realize, I suppose, that there's science behind this because the contact patch between the wheel and the road surface also has something to say about this cornering speed, centrifugal force, road surface condition, the corner. So he wrapped the car around a light post, because he think it wouldn't roll, you see. But it is what it is. The car is no longer here with us. He's still here, by the way, with metal in part of his body. But yeah, that's what, sorry for the looks of that, but that's what the car looks like. Or shouldn't look like, actually. So, on my way to university in England, central England, Birmingham, I got intercepted by the British military, offered to employ me as an engineer, and they decided they would pay for my tuition fee at the university. So I thought about it for a little bit, and I said, all right, why not? They're going to pay for it. So I enrolled, and after basic training, I enrolled on the marine engineering course. I wanted to do the aircraft engineering course, but there was a tussle between the two programs. Both want me, so it's only months later I got told by the warrant officer who was in charge of the program that he decided for me to put me into marine engineering and not aircraft engineering. Either way, I would have done them. So I studied at HMS Sultan, which is the School of Marine and Air Engineering. Then I studied at HMS Collingwood, which is the School of Weapon Engineering and Maritime Warfare. And I did some leadership at that school as well. So there you have it. So I studied electromechanical engineering. So if you imagine, I'm coming from automotive engineering, and I went and studied electromechanical engineering now. So I worked on HMS Illustrious, which is an aircraft carrier, and I went as far as the Far East with them, and I also worked on HMS Richmond, which is designed to hunt submarine, and it engaged in a lot of counter-narcotics and anti-piracy activities. Then whilst I'm in the military, all was going well, I've decided my real intention here was to go to university. And I don't think they were working at the pace at which I wanted to work. So I said, you know what? I'm going to take this in my own hands, and I'm going to determine my future. Because when it comes to like the military, they will dictate, based on how they train you, then they will decide when to send you and do what they needed to do. So I've decided to go to the University of Huddersfield. By this time, I was in that area, and I did my undergrad and master's program there. After I left there, I worked with some companies. Now, I work with a company called Chelka Technology Limited. At this point, I'm working as a design engineer. Now, the story behind me going into design engineering is that when I was a mechanic, I used to ask myself some questions like, when I tried to take some components out of the car, some of them were in some really awkward positions. How did the designer decided to put that component there? And what was the access on offer? But what I found when I became a design engineer, because I always wanted to get into the mindset of a design engineer, to make life easier. And it was good for me, you know why? Because I've been on that side of the scale. So I know how difficult it is for some mechanic. Just try to take off the fan, the cooling fan, when the engine is hot. Not gonna happen. Anyway, beside the point, because you shouldn't do it when it's hot anyway. But try to get into the mind. So I went into design engineering just for that reason. Now, I started working with a company called Chelka Technology Limited as a design engineer. And this system, you perhaps can see because of the contrast, we call Codobio. It was a hard process to decide that name. But anyway, it was developed by the theory was developed by a professor at the University of Cardiff. And he came to us and wanted us to work between us and him to develop this therapy machine. And I spent a very long time developing this. Now it went through various stages, because we started there. These are some sketches we did to begin with. And then when we got here, we did some consultation with potential customers, and they were like, we don't want, if we go into therapy, because this is for people who are suffering from depression. If we go into a therapy, we don't want something to be literally sitting on your face. You want something that is in front of your face, not touching you, but still does the job. And that's how it evolved into that. But the company, however, we used to do special purpose machinery. So all these machinery here, these are the kind of technology we used to develop. And of course, the therapeutic machine was sort of a different field. But as an engineer, especially being a mechanical engineer, you'll find that the demand or your role could vary. The only difference in everything you do is your ability to research. How do you research and get the information you need to then develop into a product? So we did that. Then I worked for another company called Innovative Technology. At this point, I was working on like cash machines. So we have cash validators, which are like coin and note. And we were doing biometrics, developing face recognition technology. So if you're walking down the street and you find that it was primarily, this is how we sold it to the public. It is for, in countries like America, where if you're a certain age, you cannot go and buy alcohol perhaps, or certain things at the counter. It could detect your age. But of course, the technologies there can be used for many other things. You could be walking down the road and that camera picks you up and tells exactly who you are. So those are some of the spin-off to that technology. And then I worked for a company called Metla Toledo. Now, this company I was working on for the food and pharmaceutical industry, where we create X-ray machines. So as you can see, the loaf of bread, that could be tablet, that could be anything, gone through the detector head to see if there's any metal in the product. And interestingly, coming back to race car, I worked briefly for Ginetta Motorsports, where I spec'd the engine for them. So I had to, just to show you some of the things I've done. That's a G40. Sorry for the contrast, but I had to spec they had a particular engine and they wanted to marry up a particular gearbox to that engine. Now, because of NDAs, there's only so much I can say. But that was part of the design I put together. Now, they had a certain engine, and the engine was now going extinct, so they needed a new engine. So they think the gearbox was good, so I need to marry the new engine with the gearbox. So I had to design a spacer plate. Because otherwise, you'd have to buy a machine to develop a new bell housing for the gearbox. And that was expensive. But also, it's only profitable if you're making like millions of cars per year. This is a racing car company. So that was a G40. Now, as a student, we tend to, when we get a project, we say it's hard. Now, I had to do my research. I end up even at the company, get all the information I need to get on the car, the capacity of the engine, the power. And I have to, they made me do, go as far as specing. So remember, they had the gearbox in place. It's just a new engine they're marrying up to the gearbox. I had to check the gearbox if it's compatible to the new engine. I had to design the spacer plate to marry them up. I have to spec the flywheel, because now with a spacer plate, you need a bigger flywheel, but you don't want to increase the mass of the flywheel because it would affect the balance of the engine. I have to check the differential, if it can take the torque coming from the engine. So there were a lot of calculations that felt like doing a PhD. Now, when you're thinking that the projects you get is hard, trust me, that felt like a PhD. So those are some of the calculations I did to prove if I use a certain final drive as opposed to another final drive, where my power curves will end up. And this is how I had to present to the company. When they turn up, I have to say, this is what I'm doing. If I do this, I get that. If I do this, I get that, based on these calculations. And then I took the engine they have, I placed it on a bench in a workshop. I use a scanner to scan the machine, get all the key points I needed. We plot that on a data sheet. I then developed the model in SolidWorks. I sent it to the workshop to get it machined. So that's when it was placed in the milling machine. That's it again in there. When it came out the milling machine, I checked if it works against the actual clutch system that they had. So that's it on a table again. That's the clutch they had in the vehicle. So check if it works. And that is it on an actual engine. That's the engine there on the workbench. So just to show you different orientation. And that's the gearbox. I'm making sure it all come together. Now, my job, fundamental job, was to get it in the chassis. I will only show you so much, but that's the gearbox with the engine connected. As you can see here, that's the spacer plate in there connecting the engine. So the job I was given is to get this engine connected to the gearbox in the chassis. That was my fundamental job. When I'm going to do differential calculation, confirming that, in fact, I went as far as ensuring that the car with this new engine could take off on an incline, with the steepest incline which is known in the country. So if that car was parked on a hill, it could actually move off from rest with the new engine. I had to do that. I was wondering why, but I'm now glad I did. Okay, so anyway, so that's the engine in the chassis. So it was a success. By the way, you see here is the radiator. Someone else got the job to put the radiator in. Someone else got the job to ensure that the mounts work for the chassis. And needless to say, they didn't complete their job. So that's a bit of my journey, just to help you, to inspire you that now that you're preparing yourself to go out there in the working world, it's not easy. The demand is going to be great, and real engineering is such. So Formula Student is now here to stay, and I speak about it with such confidence because I've done it, right? I've done it. The first time I entered Formula Student, I was awarded Best Project by the IMechE, not by the institution, by the IMechE itself. And when I was entering Formula Student, I was told, no, you can't do it. And I went for it. I mean, even the members of the team said, I can't be a part of it. So I did it and got awarded. But also, some of the benefits of Formula Student, I ended up at Silverstone Grand Prix track. I ended up racing in Barcelona, Spain, and in Budapest, in Hungary. This is the chassis of the car, sections of it for those of you who could make it out. This is a space frame. As you can see here, we had carbon fiber wishbone. This is the hub system here and the brake. there, but that is mainly the chassis of the vehicle that we developed. That's another section of it there in the workshop. And it's coming together. That's the university I went to. So now it's started come together. The steering system here, this shaft here, I literally manufactured that shaft. Because when they're making these cars, they will weld the steering system onto the chassis. And I said, no. We need to create one which we save money as a team, because if every year you have to manufacture this part, it's costing the team money. The more you can stretch your money, the better for you. So I designed a steering system which is reusable. And some years later, there was a student who came to work at my workplace as an intern, and I asked him about the car, and I said, what about the steering? He said, we're still using the steering. I said, why? Why didn't you just develop it? They said, no, it's too good. They're still using it, right? I wouldn't even tell you the story of what I had to do that, because I approached many companies and no big companies will sell you one-off item. If you approach them, they want to manufacture thousands, because when they set up their machine, when they set up their plant to manufacture anything, they want to be doing thousands, if not millions. That's the only way it's profitable to them. Not one, but we only wanted one or two. All right, so that's another orientation. That's the back, the rear of the car, the differential system. I'm showing you there. And that is the car we built. The graphics is not so good on here, but that's the car we built. Now, there was a video here to show you me at the competition, but I don't think it was going to show, so it is what it is. So the next thing I'm going to show you what to expect at an event. So that's a Silverstone Grand Prix ground in the UK, and this is an actual event of Formula E student. Having seen that, what are some of the benefits of joining the Formula Student then? So you've seen in real life application of theoretical concepts. You can develop, design, and analyze analytic skill, fabricate and manufacturing experience, planning, problem solving, technical writing, testing and iterations, financial budgeting and cost control, marketing and presentation skills will be developed, project management and time constraints, interdisciplinary collaboration, because trust me, many schools would have to work together, or faculty within the system, to produce a good car. And you will also get the opportunity, first an opportunity to understand the industry and standards and regulations. Now, benefits to the institution itself, a demonstration of academic excellence, promotion of practical learning, recognition of innovation and research, international recognition, differentiation in a competitive landscape, and it boosts institutional morale, enhance media exposure and public relations, and alumni success stories, plus many others. But it's not only for students and the institution. Of course, we're trying to get on board sponsors, and there has to be some benefits for the sponsors as well. So benefits are usually a talent pipeline, and for those sponsors who are here today or supporters of the engineering conference, you can attest to that. You will invest into the institutions, whether it be program, laboratory, whatever it is, but also there's a pool of students that you're trying to get in your establishment as employee later on down the line. And brand visibility, most of the brands you see on the cars, that's brand visibility out there. So that's another aspect or benefit of to the industry. And sponsors, innovation and partnership. Of course, in the institution, the likes of a university, you have students who are there using laboratories, going through doing experiments, and some of that will translate into innovation for your company. We're talking about, CSR opportunities as well, okay, and how you contribute to educational and professional development. There are many, many, many benefits via this program. So who can participate? Of course, for those of you who listened to this presentation before, you'll know that we primarily, it's focused on the engineering schools, basically the mechanical electrical department. But in a Formula Student competition, you have to present a business case, because one of these cars will be considered a prototype for a new business. So there's an argument around, this is one car which is built as a prototype. However, it's your intention to scale this up into a business for maybe a particular demographic of enthusiasts. You have people like here in Jamaica, you have go-kart competition. You have those who operate on various circuits, drag race, circuit race, rally race. There could be an argument for a car racing competition between a go-kart and a, Formula 1 car, or even rally cars. Okay, so you would have to pitch this, because at the competition there will be an assessment, and you have to present a business case. So hence the reason we will incorporate the business school. What about marketing? You have to have a website. You have to publicize this. You have to speak to the public. You have to get sponsors on board. The marketing team will become effective. When engineers are there trying to figure out calculations and trying to design a product, they're not developing or harnessing their marketing skills. So who's better to do it than the marketing school? So it's a collaboration. Mind you, when I did it, we had to do it all as engineers, but I tell you, take it out of us, because there are many, many times we could be just focusing on engineering stuff, but we had to. Now, how many students university usually enter? It depends on the competition. Sometimes you have hundreds of universities, so the competition is stiff. Now, that's what a typical scene could look like at a competition. But it's not necessarily the best car which wins the competition. Is the car, or the best looking car for that matter, is the car which successfully complete most of the events. Because you have speed, you have endurance, you have many, many events which you get credit for. Even your presentation, you get credit for. So when all that aggregates, that's what determines who wins. Because if you have a nice car, because I was in Austria and saw a car, a team which says their budget was 1.3 million euros. No, we never had nowhere near that. So how could you compete in terms of looks? They had some really slick cars. But it doesn't necessarily mean that translate into first place winners. Because you could be on the track and your car overheat. It's off the track, it's gone. You know? But you could have a very, for want of a better word, a crude looking car, let me just use that term for convenience. And that car could win the competition because it complete all the events, get all its score, tally up, and it has the overall highest score. So that's how it actually works. Okay? And of course, it's not an extra curriculum activity to add more workload on the students. It is incorporated into your normal credit projects in the curriculum. So it's something that you would be doing. Your master or your major projects, it will just be a part of that. So there's no additional time on you. Okay? So that brought me to the end of my presentation. I hope it was worth it. I know we had a little bit of challenge at the beginning, but we managed to get over it with perseverance. And by the way, I remember one of the speakers earlier said, perseverance is important as an engineer. Bear that in mind as you go forward, because things will not just come by the snap of the finger. You have to persevere as an engineer. Engineer is a state of mind. It's not just about the money. They mentioned ethics earlier. It's not just about, well, it's a good career path. There's a lot more to it than that to become a good engineer. If there's any question, you can see me afterwards, because we did spend some time on this presentation, and I wish you all the best in your future career path.
Thank you very much, Mr. Mason. That was really interesting. Worth the wait, wasn't it, ladies and gentlemen? Oh, yes, certainly. You know, it's funny, just when was it? Yesterday, I happened to look up Formula Careers. Just in case you're interested, there are lots of internships there available, open now, Formula Careers. So if you found that interesting, when I say Formula Careers, all of these Formula One companies, they're actually seeking interns, people who are just leaving university this year. So look it up, formulacareers.com. All right, but come back here, you know, when you finish when you finish your internship or a few years in the industry, come back to Jamaica, man. All right, so we are winding down today's activities in this room, and our next presentation will be a sponsor's address, and that is from Pepsi Jamaica Limited. Miss Corona Atkins will be presenting on behalf of Pepsi. And you know Jamaica is a Pepsi country.
Good day, everyone. I will not be full of knowledge about engineering like the other speakers, but it was my pleasure being here and keeping you guys hydrated. So good day. Good day, esteemed faculty, distinguished guests, and talented University of Technology School of Engineering students. It's an honor to be here today at the School of Engineering Project Conference 2024. My name is Corona, brand coordinator, and I'm representing Pepsi today. We're not just thrilled, but truly inspired by the incredible innovations and projects that you, the brightest minds in engineering, have developed. This year's theme, Engineering for the Future, research and development for the continued growth of Jamaica, resonates deeply with us at Pepsi-Cola Jamaica. Engineering is not about building and creating, it's about envisioning a better future, solving complex problems, and driving progress that benefits society. Your work is at the heart of the vision, and we are excited to see how your innovations will contribute to the continued growth of our country. Jamaica land we love. At Pepsi-Cola Jamaica, we understand the critical role that engineers play in shaping the future, because we do have engineers at Pepsi, from electrical, mechanical, industrial, and some chemical engineers. We do have some at Pepsi-Cola Jamaica who grace these very same walls. Like Javan Saman, I don't know if anyone here knows him, but he was definitely thrilled to have us sponsor this event as well. That's why we are committed to fostering innovation and investing in cutting-edge technologies. Recently, we launched a new production line, a testament to our dedication to modernization and efficiency. This state-of-the-art facility enhances our production capabilities and underscores our commitment to sustainability and reducing our environmental footprint. But technology and machinery are only as good as the people behind them. That's where you, the future engineers of Jamaica, come in. We value your expertise, creativity, and passion. Your innovative spirit drives us forward and keeps us competitive in an ever-evolving market. To the students here today, I want to emphasize that your journey as engineers is just beginning. The projects you are working on now are laying the groundwork for future breakthroughs. At Pepsi-Cola Jamaica, we believe in the power of young minds to bring fresh perspectives and novel solutions to the table. We look forward to seeing how you will contribute to our industry's future, whether through advancements in production, sustainable practices, or groundbreaking research and development. As you continue your studies and embark on your professional journeys, remember that the world is full of opportunities for those who dare to innovate. We at Pepsi-Cola Jamaica are eager to support you, collaborate with you, and learn from you. Together we can drive Jamaica's growth and development, ensuring a prosperous future for us all. Thank you for your dedication, hard work, and commitment to engineering excellence. We look forward to the incredible contributions you will make in the years to come. Enjoy the conference, and let's continue engineer a bright future together. We have Tashika here from our HR department as well. So for persons who are interested in working at our plant in the near future, you may visit our table outside on the break and sign up our registration form. Thank you so much for having us.
Thank you very much, Ms. Atkins. So you see how many opportunities have been presented to you today? I hope you make use of them. All right, so there is a presentation going to be made now to you, Ms. Atkins, so we invite you back. Just to say thank you. All right, the camera. Thank you very much. And as was said, please make sure to visit the booths outside, and we really say thank you to Huawei, JPS, Loring Consulting Engineers, Pepsi, GIE, PERB, Donut Desires, and Tropics 365. Thank you to our sponsors. All right, so this ends today's section of presentations. We now are going to move into the major project poster competition, which is outside. I know you all have your posters out there. The assessors will be walking around, so please make sure that you are beside your poster and you are able to answer any questions that they may pose. I think Mr. Andrew Johnson will want to mention something about the poster competition. He's right here.
All right, good day, everyone. How are you guys feeling today? No, I sound hungry. How are you feeling today? All right, great. All right, so before I dive into the poster commission, I must say the poster commission itself is something that is very sentimental to me. All right, so when I left school, I was called back by Mr. Alexander and the team from Electrical to be a part of the panel for the poster commission. Little did I know that 2 to 3 years from then, I'll be here in this position. I was the person that are actually coordinating the commission itself, right? So for that reason, we try to see how best we can improve the process as it is. So in the past, it was compulsory for the chemical students to have a submission because a part of their grades would come from the poster commission, right? But I'm pleased to announce that going forward, starting this year, we have a new approach where all disciplines actually have a grade allotted for the poster commission. So you guys can fulfill that. It's by no coincidence. With this new approach, I must say, we have an increase in submissions. Right? Because, of course, in the past, I remember, even in my year, I thought we had 3 submissions, but we had a lot of groups. Because nobody, prioritized commission because they said that no grade was allotted to it. Right? So, for example, electrical program, I think is only 1 group. You have an outstanding poster for this year. So it shows that persons are really interested in what is being incentivized by the commission. All right, so for this year, we're going to be transparent as possible. You guys understand exactly how we go about the process. All right, so usually we have assessors, and each assessor would be grading all posters. Now, even my experience, I realized that when I reach maybe the 15th or the 16th poster, I get very tired, right? And that might affect the grading process as it is. Not saying that I did, but saying that that may affect it, right? So what I've done this year, we have the same amount of assessors. Usually we have a minimum 12. This year I think we have 11, yes, but usually 10, 11. And this year we have each assessor grading 12 posters, right? Also, in their program, because we're engineers, to ensure that all posters have at least 4 persons grading them, right? So not all assessors will be grading each and every poster. We have an efficient way to ensure that the quality and the assessment of each poster is properly done, right? Also, we make sure all the assessors have the flexibility of grading additional posters if they do desire, right? So after they pass the 12, they feel like they have enough energy to continue. Yes, they can go ahead, right? And of course, this will help us in proper tabulation, and there's a booklet that was made available. So instead of giving sheets and a grade, we have a book, we have made things official. And we did it all for you guys. What this will help us to do is help students have a better appreciation of the process. And not only that, we are attracting the external stakeholders. We want them to know that we are doing serious work here at the School of Engineering. And of course, it's a proper transition for you guys as you leave to go in the working world. All right, so with that being said, tomorrow, you guys should be excited. We're going to have an award ceremony for the winners. So as soon as we finish assessment today, we'll be tabulating the grades. And of course, we'll be having first, second, and third place from each program. First from each program. Top 3 for the school, right? So be excited, and I hope you guys get a better insight of the whole process as it is. Thank you.
Thank you very much, Mr. Johnson. So we end here, inside here now, and you are to move to outside by your poster. Have a good rest of the day. Enjoy yourselves. By the way, before you all leave, please remember that we are starting 9 a.m. sharp, so please be here by 8:30 tomorrow morning. All right? Come dressed up looking really good and professional tomorrow.